Just a second. Yeah. All right, a momentous occasion. I see the first green post-it. So someone has succeeded? Okay, great. 2 green post-its. 100% success so far. Hello, we'll get started in a few minutes, but while people are setting up, I'm looking, just to let you know, I'm looking for the back of your laptops to see if there's a red note on it, in which case I will help you, or Andrew, who will be here shortly, will come by and help you get set up. So if you're having any problems, put the red one on your laptop, and when you're done setting up, please put the green one. Hello, good morning.
In person, you're taller than I expected.
Have we not ever met in person? Oh my God, that's crazy.
I know. Yeah, short person.
You're normal.
Yeah.
All right, so your job is to go around looking for a red sticker like that guy has and say, hey, what's the problem?
Yeah.
Oh, but before that, is Nabari set up? So what do I need to write on here about using Nabari?
Yeah, I put up the slide. But,
Oh, on that.
you can also
You put it on the slide?
Yeah,
Okay.
that's red.
So everyone, this is Andrew. He'll be wandering around helping anybody who needs help. If you need him to help, stick your red Post-it. I see one out there already, so he's going to go for it like a shark. And if you look at the Slack channel, there are Andrew tells me there are now instructions for using Nabari. You're welcome to use either your own laptop or Nabari. The computational resources involved here are not going to be major. We're going to look at data sets of a couple million points. That is nothing for these tools. That is no problem for just about any laptop you have, unless it's 10 years old, I guess. So I would recommend you run it on your own laptop, because then when you walk out of here, it goes with you. And your setup will just keep working, so you can try things out on your own. But if you have any problems with your laptop, any issues whatsoever, use the Nabari version. It should also work. Unless everyone in the whole conference is also using the Nabari version. It should be on the Slack channel, according to Andrew. Post-its are on the table at the back next to exciting stickers. And I almost have Slack working on my phone, so give me just a minute. Instructions for installing there. So Andrew, where are the instructions for Nabari? It's in a thread. Okay. Okay, hang on. I'll show it here. I'll destroy everything for a second. Latest thread. I do not see that.
Oh, I mean, our thread.
Oh, he put it on our internal Slack. That doesn't help any. So are you not on the, you should definitely be on the
Yeah, I can post
conference
it in there
Slack.
as well. Let's see.
Please do. So I tried out Nabari, but it was several days ago. I've completely forgotten everything to do with it. Meanwhile, Andrew's been in charge of that. All right, I have it on my phone, so I will be able to respond during the tutorial now. And I see Andrew has put it up here. Excellent. All right. I see a smattering of green. That is great. Please use red if you are having any trouble. So I'll go ahead and get started to keep this on time. If someone comes in and sits near you, can you please help them along, because this slide will no longer be up. And they will know, hopefully they will know to go to the Slack channel already. But if somebody comes by and looks lost, or even if they don't, just say, okay, are you ready for the setup? And they give you a thumbs up, great. But otherwise, please help out. I'm just one presenter here, and there are a lot of you. Okay, that's apparently, I'm just checking to see what it says about me. That's me. Hi, I'm Jim Bednar. I go by James in publications and anything official, because I was an academic for a long time. It was always James A. Bednar, so that all citations are always to the same entity. But in person, I'm Jim, so apologies for confusion. I currently work at Anaconda. Andrew has worked for me for more than a year now, and this is the first time just now that I'm meeting him in person. My team is highly distributed across the globe. He happens to be nearby here. Just a little bit about my professional background. As a former academic, I got used to writing open source software in Python for my own research and for the research of the people in my lab. And when I was looking to go to industry, since my wife, we were in Scotland and it was cold and gray, and my wife is from Texas, I'm from Texas, and we wanted to move back to sunnier climes. We were heavy users of Anaconda. I joined Anaconda, and then I reconstructed my entire research group inside of Anaconda. We kept using and developing a lot of the same open source tools, hired a bunch of my old PhD students. we carried on in a quasi-academic way, but now really focusing on the tools rather than on papers. So if you look at my CV, you'll see publications stopped around 2015, but software releases really ramped up at that time. And what I do at Anaconda is I figure out who in the world needs something and has a budget, and we figure out if it fits into the open source tools that we use. And then if it does, we set up a contract. They pay us. We write open source, give it to the world for free and to them. And whatever the next person that comes along, the open source tool is a little bit more powerful and a little more powerful. And a lot of times we have these multiple contracts with different companies and agencies where we develop things for one, and then that we show it to the other one, and they improve that, and they go back and forth. And so it's this arms race to fund open source and develop cool tools, but also solve problems every day. So basically, I'm paid to connect the really smart people like Andrew on my team with people who have problems that open source could address. So that's what we do here. That's where these tools started, like I said, when I was in academia, but there's no way they could have progressed at the pace that they have. Now we have 10 full-time developers working on things. It was always a random collection of the latest grad student working on things with varying levels of attention to detail and commitment to open source and so on. So that's worked out for us, and it's worked out for you if you use these tools. The tools are all open source. I won't show you anything proprietary. I'm wearing my Anaconda shirt, so they will pay for me to be here. So that's probably as much as you'll hear about Anaconda. This is run really between us and Anaconda's clients. They pay us directly to work on the tools. It's not really, none of these things are products of Anaconda. Do buy our products. That's what keeps the lights on. But this talk is not about that. And before I go any further, let me introduce some of the important people on the team. I said 10. Clearly it's 9 if you count me. So here's everybody. I've moved on to primarily arranging funding and developing strategy. Philip Rudiger was my old PhD student. He's now in charge of HoloViz tools and making sure everything adds up, coordinating everybody else. So really this is now Philip's project. And everyone else on here contributes, if not full-time, a whole lot. Mark, for instance, he doesn't report to me in any sense. He's an independent person, an independent company, but he contributes as much as a full-time person somehow, and has another job. I don't know how he does that. The rest of the people are one way or another funded by the projects, the contracts that I arrange. And everybody has their own specialties in terms of library, but everyone pitches into the overall HoloViz project. So before I launch into the actual tutorial, is there anyone who needs particular help or has a basic question like, is there something you want to ask to be sure you're in the right place? Like, is this tutorial for you? Which you'll also probably be able to tell about 5 minutes in. Okay, sorry, I have to put the font on this screen, as you can probably see, is extremely tiny, so I have to put on my glasses whenever I need to stare at any of that, and then I have to take them off to see and view people. So apologies, it's going to be a lot of that. I'm starting now. All right, I arranged all these tabs in the right order so I wouldn't forget everything, so I'm going to start from the left. We did that one. We did that one. If you want to get data without using Anaconda project, if you look inside an hang on, this is probably a lot better. Let me move that down just a second. Okay, there's a question. Can you download the data files without Anaconda project? Yes. If you download an Anaconda project, it'll just be a zip file or a tar file. If you unpack that, in there's a YAML file called anacondaproject.yaml. In there is all the data, all the information you need. It'll tell you what data files and where they come from. It's a URL. Grab it, download it yourself, do what you like. Anaconda project just wraps it up in a little reproducible recipe. It's something that I think should be vastly more popular than it is. Nobody knows about this tool. They know about Conda, but a Conda environment by itself does nothing. And a Conda project is a Conda environment plus code to run in that environment plus a recording of the command to invoke in that environment plus any data files you need. And together that's a reproducible unit like a tutorial. It's amazing. Everybody should use it. But for the purpose of today, I don't care whether you use it for this tutorial. It is what the instructions say, so if you're not using it, you're going off grid, but it's totally okay. We won't be able to help you as much. All right. So I'm here today to talk about the HoloBiz tools and why they might be relevant to you and what they can do for you. Somebody's reporting a Nambari issue. Andrew, if you could take a look at that. As I mentioned, these are some libraries that my team has been developing for the oldest one, that's since 2003. I don't know if there's anybody here who's born since 2003, but we do have a teen track, so it could be. In any case, the oldest is Param, the second oldest is HoloViews, probably the third oldest is Data Shader, then Color Set, then hvPlot. But then we'll focus on the two at the left because these are the highest level ones built on top of the others that expose pretty much all the functionality of everything else in an easy to use interface. The power of these tools is from the lower level tools that they're built on, just like the lower level tools like HoloViews, that's built on Bokeh and Matplotlib, things you've heard of, important libraries. These are built on top of that to address the visualization needs of scientists in particular, or analysts, or anybody working with data. So these are building on the shoulders of giants, as it were, but we're going to at least maintain the fiction that you can focus only on panel and hvPlot for the duration of this tutorial until, I guess, around tutorial number 8. So there's several of them. At some point, you do have to figure out how things are done behind the scenes, but we're hoping to get you started preferably with minimal learning of API, maximal learning of functionality. Wow, cool stuff I can use, rather than, well, that looks good, but how do I invoke it? Hopefully it's going to be all in terms of APIs that you already understand if you know Python, particularly if you've used Pandas, Xarray, anything like that. Lumen I should call out as a special case. This is the only tool that focuses on people who are not writing Python. Lumen exposes the power of all these other tools in 3 different ways, either as YAML, so it's a fully declarative way to build on all of these other tools, or as a GUI, which is very janky. I mean, it works. It's not the best experience. It's not like Tableau, not that polished. Or our latest thing that Andrew works on a lot, an LLM-based interface where you describe the plot you want. You give it a data set, and then you can ask questions to the data set, build up all of these tools using human language. So basically, you can use Python, a GUI, or natural human language. Everything's got its advantage. The natural human language is great when you have no idea what you want, and you can describe it, but you don't know what it's called. That's a great way to use these tools. That's all still under development. I think it's been announced. I think it's publicly available, but we are not going to focus on that. We will focus on the 2 on the left. Usually, I start out the tutorial like this. We've been at SciPy for, I don't know, a decade, giving tutorials. Usually, what I do is get trapped by this page here. Apologies. The Zoom is no good here. I usually start showing examples from here. I will not do that because I will show them all day, and then I will wake up in an hour or 2 and realize, oh, I better get to the actual tutorial. There's tons of cool stuff here. Explore that at your own pace. I will focus on one, which I didn't even verify worked. Oh, that's annoying. We'll get to it in a second. We'll see if it worked. Let me get it started right now, though. Okay. And we already showed the developer team. And this is great. I have it all set up to remind me of the things I'm supposed to do in order. This is another section that I am not going to talk about. but you should know about. The tools that we're talking about here, like hvPlot and Panel, back when I was a professor, I taught a course on software architecture. This was in the early 2000s, and I talked about software reuse and open source as magical, wonderful things that could happen to people someday. They did happen. The world is now, thanks to Python's ease of gluing everything together, everything in Python is all depending on everything right and left, and putting together something that solves problems is a matter of finding the package and attaching it to other packages rather than starting from scratch writing stuff. And the packages I'm going to tell you today are part of a whole community of tools that are mutually aware of each other. I just tried to find my own tutorial in the SciPy program, and I found mentions of these tools in other tutorials that I don't even know about. It's like, okay, yeah, that's somebody else is talking about hvPlot in some other tutorial right now. And that's because these tools are part of a whole, I don't want to say movement, but a whole push to level up what Python can do, in particular to make it scalable. So that it's not just for toy problems with a few bits of data, so that it works with the largest problems, terabytes, petabytes of climate science data in particular. We work with a lot of climate scientists on scaling these tools up to the very largest problems. And to do that, our little tools are just one little part of an entire approach that you have to figure out: how do you store your data in an efficient way? How do you access it? How do you work with it in Python, depending on whether it is a tabular data set, a multidimensional data set, where they're using GPUs, et cetera. Then how do you write fast code using it? How do you scale up to very large problems? And only then connecting all that up into the visualization tools. That's the focus. But if you want to learn about all these others and read a paper from last year's SciPy that I wrote trying to explain how does all this add up to solve problems for science, go to pydata.org to see my very sketchy website, but my pretty good paper. And you can read a lot about the background. Again, this is all stuff I'm not going to talk about. All right. Looks like this is running. AV people, apologies, I don't know your name. Is it possible to turn the lights down on this part? Keep the projector bright, but the room lights lower? Okay, well, if it's not practical, don't worry about it. All right. If you want to, well, actually, no, I was going to point you to where you could do this on your own computer, but if you're all hitting that at the same time, do not go visit to do this on your own computer. Just get by with the somewhat limited. It's very vibrant on my screen. It's kind of washed out over here. What you're looking at is one example app of the type that I would like you to walk away from this tutorial being able to build yourself. Now, you probably won't be able to build it exactly like this. This took some thought, and we're still not happy with it. We're iteratively improving it all the time. But this is an expression of the types of things that these tools, like why not just use Matplotlib? Why not just use Bokeh? This example should show you why. Because we're building on those tools, but we're offering insanely more functionality, a whole lot on top of that that's not present. All right, and so I have this version right here. It looks like it's running on a public server. That's a real URL. Please do not visit it right now. We pay a certain amount of cloud cost, and we get a certain size machine, and if everybody uses it at the same time, it will go down. So do not visit that, at least till the tutorial's over. I also have it running on my laptop here. The same thing, it doesn't require any special resources, but I'll switch back and forth between the two. So what this is showing you is GPS locations, about 200 million of them in total for ships as they near a US coast. So they have a little ping and they just say, hey, I'm ship number whatever, there's an ID, and they have to, by law or international treaty or whatever, they have to declare who they are so that you can tell whether a hostile ship is approaching, or just to manage a port. And this is where we are. I think we are currently just off the screen here. You notice what happened? This is great that it took a little while to update. See what happens here. I'll use to explain what's going on here in a second, but I'll wait till it's got, okay, we're right here. That's Tacoma. And what this is doing as I pan like this, this is a client-side application, so it's JavaScript running in a web browser. It's noticing that I have selected a new viewport. It sends a message to the Python server, which could be a very different machine. In this case, it is a different machine. Somewhere in AWS US1 East, there's a server running. So as I move things around here, or if I zoom or pan or whatever, you see there's a lag from whatever service it's coming from. If I zoom in, it'll redraw it. So it uses JavaScript to collect events in the browser, JavaScript to display the result, but in the meantime, it's Python. The request for an update goes to the server. The server goes through 200 million data points, renders it into an image, sends the image down to the local browser, and that's what you see. And it's, you can even, if you have really good eyesight, you can see individual little dots. I'll zoom in a lot. And you can see it has not updated yet. Now it's updated. And if I zoom in enough, eventually you should see the individual data points that are involved here. Each one of these is a ping. You'll see it hasn't updated yet. Hasn't updated. It's waiting for the server to process it, send the data locally. And we reached the edge of what tiles are available. That's great. So each one, you can see the dots are quantized. They chopped off some precision on the GPS. I don't know if that's to avoid military applications or just convenience. I don't know. And then if we go back to where we are, I forget exactly. Anyway, the point is that here we are working with 200 million data points in a web browser. We're right here. I recognize the pattern of the ships. This kind of weird finger. I don't know if I'm not from Tacoma. So I'm working in the web browser. My data set could be enormous at some faraway computing center somewhere. It doesn't matter. This is fairly slow. It's not using, it is equipped with Dask. It could be using enormous resources to satisfy my request very quickly. Then it'd be down to just a latency from that server to here. It's just a single machine, weaker than my laptop, running somewhere in a data center. And the data is there, but I'm interacting it with in a web browser here, and I'm fine. I mean, it's not the fastest, but it could be, it's workable. And this is requiring pretty much every tool in the HoloViz suite. Oh, I forgot to point out, even though it's just sending an image, it's got hover information. You probably can't see it. When you connect to the projector, all the sizes get wonky. But you probably can't see it, but it's telling you the exact ship that's present here. I assume these little circles will tell you the length of the anchor of the ship, that it just goes around there. I'm not involved in shipping. That just looks like, that must be an anchored ship. But I can find out which anchored ship. Apparently that's the Cheyenne Arrow. Okay? And the way that works is when it renders the image, it also keeps track per pixel of what's in that pixel and sends that down too. So when I'm interacting with it, I can still select. I can still use hover and so on. So, like I can click on it and it will update it down here. Again, way too small for you to see. I can do things like get rid of the map to just see the data, etc. So being able to work with data, being able to, regardless of how big it is, to be able to work in a web browser so that it doesn't matter what operating system you're using. These tools are all open source and OS agnostic. They don't care whether you're on a small machine, a big machine. And they don't care whether you're trying to develop for the web, like this application, or for publication. In that case, you usually use the matplotlib backend rather than Bokeh. And so this is kind of encapsulating what we want people in Python who are working with data to be able to do. Easily change whatever they want aspect of the data, easily just get to work doing things without having to learn web technologies, without having to think a lot about servers or any of the other details. So that's the pitch. I suppose I should zoom out. Really, there's data from all the US here. That's why there's so many points. So, and there's cool stuff going on everywhere if you zoom in. I'm from over here, no boats over there. But you can see really cool patterns like fishing vessels go along the shore, cargo vessels apparently go in lanes. I didn't know there were lanes. There apparently are lanes. Look at that. So on. All right, so hopefully you'll be able to do this with your own data by the end of the tutorial. We will not be developing this application that has 200 million data points. The same tools could work on a laptop up to about 1 billion, 2 billion data points, but it's greatly scaled down so you don't tax the Wi-Fi and so on. We'll be working on this little application, which is not too different, but it's a collection of earthquakes data, and this is showing the global population as a raster, showing with this color bar, and it's showing you where large earthquakes were located, and so you can somehow see which earthquakes might affect people. And then you could select individual earthquakes, look for the events around that time, and aftershocks and so on. So I'm not an earthquake expert. This is just an example of data. Oh, this is all. Formatting's all messed up. You can, if you have things you want to select about your data, you can. If you want to vary parameters, you can. Things update. This is the actual application we'll be building up towards. It's not, nobody spent any time making it pretty. Really just trying to make sure that you get power to do things with your own work. Okay. Now I should pause and take a breath. Look out for any reds. Andrews, things that are generally working? So Namari's there as a backup. Your laptop's a backup. Whichever one on the day works, doesn't matter. Okay, so everybody please go to Jupyter. And you'll want to start with the index.ipynb file. No longer the setup file. So you can ignore that one now. And you want the index file because the index has everything in the right order. Setup was the first one, but then we'll go through each of the other sections in order. We will, how many, need a vote. The breakfast, I believe, is cleared out at 9 o'clock. So if anyone's still hungry, does anyone want to make sure we take our first break before 9 so you can get food, or is it okay at the more natural starting point, which is probably 9:30, where you could only get coffee and juice and such? How many votes for do it when there's food? 1 vote. Okay. You scoot out and get some food whenever. Otherwise, we'll stop at a natural break. I will not be offended. Go for it. And if I ever fail to keep zooming this web page in to try to make it readable, please remind me, raise my hand. Just raise your hand and point to it. And I'll like, oh, okay. All right, that's the projector and Chrome are not getting along. Okay, so we're through the quote 15-minute of setup and overview. Not bad, usually it's an hour. I think I achieved something. And then we'll dive into actually plotting things. Oh, shoot, we didn't finish overview. I will go through overview very quickly. It is not a big deal. So you can read that at your own pace. But the background is Python has tons of visualization tools. In fact, I run a list of them at pyviz.org. These are lots of visualization tools. Panel is a dashboarding tool. When it was created, there were 3 others. This is now the current list of dashboarding tools. Python has exploded in popularity. It is, there are a lot of contenders, a lot of people vying for your attention, usually a bunch of different companies trying to grab you. We've listed the sponsors on here so you're aware of how companies are related to it. Think about what they might be pushing. Anaconda is listed next to our tools because we do work at Anaconda, but the actual development is driven by our customers rather than Anaconda itself, or by us rather than Anaconda. It's not part of Anaconda's roadmaps, it's part of our customers' roadmaps. So we talk to like-minded customers. So that's our situation. And we're also sponsored by NumFocus. So the tools I'll talk about today are Bokeh, the second one here, and Panel, the 5th. And other corporations have their own agendas. So I really can't even summarize what they are or why they support open source. They each have a lot of reasons for doing so. Yes?
Can you give some advice how to choose one?
Well, do not choose dormant projects. That's easy advice. These are projects at the list that if you ever find yourself saying, should I use that? The answer is no, you should not. And there's actually a link in here, I think, somewhere. Anyway, these projects are all ones that the original maintainer says, don't use this project. I don't maintain it, you should not use it. So if it's on there, do not use it. But if you look at this, these are sorted by rough popularity in terms of total downloads. If you choose something near the top of the list, you'll have company, misery, and company in some cases, because basically these are popular tools, so you're going to be able to find, if you search on the internet, if you ask a generative AI program, they will know about these top tools. They might not know about the lower ones. But there's a reason somebody created these. They were frustrated with the other tools. These might be the best thing ever. That's your choice to make. All we're doing, this site is very objective. I can say nothing on this site about use my tools. You'll see that they aren't, I don't put a little star next to this is the ones that you should use. This is totally just a listing of tools. If you ask me personally, you should use our tools. If you don't use our tools, you should use some of the more popular ones. If you look at the download counts, there's a precipitous drop somewhere after, it's so hard to read here. So Panel's downloaded 1 million times a month. The next one down is downloaded 100,000 times a month. And then pretty quickly you're down into the 30,000 a month, 100 a month, and so on. The ones that are low counts, you probably are going to want a personal relationship with the author there because you'll be the first person who's tried feature X. So I wouldn't do it unless that one had a very specific feature that I cared about. Beyond that, I can give other advice, which is the core libraries will always be there. I mean, they've been there for a decade, more than a decade. They will be available. And then this section builds on those core libraries. It says here which it's built on. This is good to know. If you're built on matplotlib, you get certain amazing power and you see certain limitations. And if you're built on Bokeh, you get opposite power and limitations. Everything in here is kind of interchangeable. If you know how to use pandas.plot, you can use Xarray.plot. If you know how to use either one, you can use hvPlot, which is what I'm talking about. If you know how to use hvPlot, you can use cufflinks or pandas bokeh. These all have the same API. So I would strongly recommend if your usage falls in what this API covers, pick something from here and you'll be protected against some library having a problem. Beyond that, I am a strong believer in high-level libraries. I think you should choose something from this list or this list rather than using one of these directly. I just believe the underlying, do you want your every day making a figure to start from scratch and build it up piece by piece by piece, or you just want the figure type that you want? I believe as a scientist, I do not want to spend all my day visualizing. That's what I do now because that's my job. But certainly when I was a scientist, it was not my job. My job was to understand my data. And I think you should choose a high-level tool that really encapsulates what you're trying to get at for your data. So that's my advice, but the PyBiz site is just completely generic. Okay. This is an older version of the app that you'll be developing. So we're done with that. Now let's actually dive into it. Again, any problems? Anyone raise their hand and make sure that Andrew sees you? Okay, you should make sure you have the O2 plotting up on your screen. It looks like the size is pretty good. This section explains what I just said, that you can, if you know the Pandas.plot API, you can use any of these tools, and you should. Oh, there's even some that aren't in there. PD Vega. I don't know if that's still supported. And Plotly Express only sort of supports that. That's why it's not on the other list. It's inspired by the .plot API, but it's somewhat different. Okay, so you should read in this file. This is 200 million points, or at least it was last time there was briefly a different file, so let's actually see which one this is. Ah, shoot. It's supposed to be 200 million points. Andrew, I ran a fresh one. It was supposed to be 2.1 million. It's still... I won't mess with it now. Anyway, there was briefly a smaller version of it. You're not being tricked or anything. It's supposed to be 2 million points. Just there was a mix-up with the files. That's currently what I'm running with, but it's all right. It doesn't care. And so if you run it, how many are getting? If you run this, have you gotten to here? And if so, how many are getting 700,000 rather than 2.1? How many are getting 2.1 million? Okay, so somehow you're getting the different versions. Anyway, it shouldn't matter for the purpose of the tutorial. You should be seeing a data frame with a bunch of columns in it, a bunch of missing data all over the place. We'll come back to that. Some latitude and longitude. That means we've got data points and located on the Earth. This is not an earth science talk, despite it saying USGS and being about earthquakes. It is a talk about data. And my experience has been when you talk about data that is situated on the Earth's surface, people know what you're talking about. If you talk about data in an abstract feature space, they nod their heads. They don't know what you're talking about. So everybody's from a different background. It doesn't matter that it's not geoscience for many of you. Don't worry about it. It's just data. There's very little here that is specific to geoscience, and we'll call it out. It's really about just data of any size, any type. Whatever the data is, you're going to be displaying it on a two-dimensional screen, and so it'll look like a map, whether it was ever a map, so may as well just make it be a map in many cases. All right, and we'll be comparing to other tools which are not built for large data, so we also take that and throw away nearly all the data, which is what many people do if you use non-HoloBiz tools. Step one, throw away all your data. Sample it, select it. Oh my God, don't do that. These tools are built to say, don't ever throw away your data. Always show all your data, except if you're making a little toy example for for your CI tool or to make a point. But these tools are built to handle your raw data, no matter how big it is, whatever you've got. Visualize it all, because it was very expensive to get. Don't throw it away. So, of course, we're going to throw it away immediately here, but that's to show off other tools that where it doesn't make that much sense to have large data sets. Okay, so just to level set, this is not our work. We are not developers of Pandas. We contributed 2 or 3 things to Matplotlib. We're not massive Matplotlib developers, although we are grateful users of Matplotlib. That was what made Python work for science when I was first starting. Like, we had other libraries before Matplotlib that we used that were horrible. GNUplot, if anyone remembers that. And then Matplotlib came. It was amazing. But our tools are built on top of that and going way behind it. So if you use Matplotlib, here's the dot plot interface. So I just pronounced this dot plot because if you've got a data frame, you do dot plot on it. And if you do that and you tell it what you want to plot, it'll give you a plot. And if you are imaginative, you can look at this. Well, I've looked at it so long I can see the Earth. I don't know about anybody else. We are up here. This is the Pacific Northwest. This is South America, Alaska. This is the Mid-Atlantic Rift, I think that's called. It's certainly in the Mid-Atlantic, and it seems to be a rift where a lot of earthquakes happen. Europe, probably Sicily, somewhere around there. So you just easily get a plot out of the dot plot interface. It's great. And you can try changing this to widget. You'll get some interactivity. Matplotlib has interactivity. It was built for native GUIs, and so it's a little janky when it's in the web browser in Jupyter. It works. It's just not full JavaScript style interactivity that will be our focus. So if you want to use hvPlot instead of dot plot, it's pretty simple. You import hvPlot.pandas, and what this does is register a hook with pandas objects. Xarray offers this, various libraries offers this, where you can say, you can add your own methods onto those objects. Here we add the .hvPlot method. And we could have overwritten the .plot method, which is supported. You can totally do that. I think that's confusing. We like to keep it separate, but it's exactly the same. Anything that worked for .plot, it's very likely that you just change .plot to .hvPlot and you get this. And we certainly keep them separate for a tutorial so we can compare .plot to .hvPlot. So if we do that, you'll see that you get a very similar looking plot. The aspect ratio is different. It doesn't know that it's geodata. It has no idea that the aspect ratio should be anything in particular. So it's a little different one than this. That's just a different default from Matplotlib to hvPlot. The color is different by default. You'll notice that it has immediate interactive features. So you can hover over data points. It has panning. It's got zooming. You can zoom along or pan along individual axes, zoom along individual axes, zoom to look in a box. These are all done by this tool. The blue means that it's active. The zoom tool no longer works when I turn off wheel zoom, but now it does. So here I'm on my Mac. I'm using 2 fingers and pushing up to zoom in, pulling down to zoom out. On different machines, you might have configured your gestures differently, but you should be able to find something to zoom in or out just like you would on a web page. And you can also use pinch, but that's very slow. So don't do that. Definitely the 2-finger up and down is the way to do it. So this is step 1, which is using hvPlot, you immediately, with no work at all, well, you added 2 more characters, you got an interactive plot that'll help you reveal the data. Yes?
Could you say in like 10 seconds how you register, what's the mechanic of how you register a new method on
I think it's called a accessor. Andrew's nodding, I think. So if you search for Pandas accessor or Xarray accessor, I believe that's the mechanism. It has been many years since we had to mess with that. When we first did it, there was no accessor. We just monkey patched it. But then they said, the people noticed what we were doing, and they said, maybe we'll provide you an API for that. And so there's now an official API. You can use that for your own stuff. If you want to add your own functionality supported by these libraries, go for it. Okay, time for your first exercise. This is the most basic plot. Now do some actual typing. So it's asking you to try changing the alpha. Okay, well, how do you change an alpha? You notice, you just look, you see, oh, there's an X and a Y, maybe there's an alpha. So I'm trying to be exaggerated here to make it, to guide your thinking in future cells here. This is what I'm expecting you to do, to read what I'm saying in words and then to try it. Alpha. equals 0.1. And then let's try it with quotes just to mess it up. Oh, I did not like that. Didn't have a good error though. Then we try it without quotes. Okay. What alpha does is change the alpha's opacity. Many people would say alpha is transparency. They're wrong. Alpha is opacity, because high values of transparency would be transparent. High values of alpha are the opposite of transparent, opacity. And so if you add opacity to this plot, it gets better. Now, what's better about it? Well, you can see that in these spots, look at all those things that are overlaid. At the cursor location, bokeh is reporting that there are so many data points that go off the screen. But I can actually see that when I use transparency, because I can see when there's one data point, it's mostly transparent. Sorry, opacity. It's nearly transparent. It's very low opacity of 0.1. But if I get a stack of them in a row, it becomes opaque, and I can see dense regions versus less dense regions. This is called overplotting. We'd spend a lot of time worrying about overplotting. You can read all about it at datashader.org. We have a tool that just completely eliminates overplotting. That's what you saw in the ship traffic example. The reason those plots are so gorgeous is they're adjusting for overplotting at every pixel automatically and just maximizing the amount that can be given to your eyeballs with no parameters or anything. Anyway, here we've adjusted a parameter for alpha. It was obviously just for some random number that we picked. Could have picked whatever we want and gotten different results. That's a very bad feature of a plotting library. You shouldn't have results that depend on your parameters, because this is designed to reveal your data. You can use these for bad, to hide your data, to convey things that are what you want them to see rather than what's there. So we discourage fiddling a lot with those, but sometimes you need to just to tell a certain story. So we're going to focus mostly on things where you're not fiddling a lot with parameters. We'll try to use tools that don't require that. But obviously you'll need to at some point. All right, so another exercise. So just show of hands, how many people were able to paste code into a cell and edit it and do something? Success. In fact, that's the 8:49. That's minute 49 is the fastest that has ever happened. I tend to digress. Yes, let's digress.
Can you fine-tune the plot after you load it, like change the X label or something?
Yes, you can do. Now's as good a time as any, since we just started. hvPlot has a function call interface where you have arguments and you pass them in there. It supports lots of things. I don't even know how many. There are a lot of options that you can provide there. But then what it returns, we'll get to in a minute, is actually an object that you can grab a handle on and then keep adjusting it over time. So we'll get to this, but what actually happens here is it returns an object, and then a plot is created, and that's what's shown to you. But the object that was returned can become part of other plots and can be manipulated, and you can get at the data. We'll get to all of that, but in this most simple case, it looks just like the .plot version from matplotlib. But it actually can do a ton more, which is why we're here. Otherwise, there'd be no point. So second example, let's try a hex bin plot. That's one way of addressing the overplotting issue, which is to divide this image into bins and then count how many points fall in each bin and report that, rather than fiddling with alpha. So let's make sure that still works. Get rid of alpha, and it says we need a hex bin plot. And I'm looking at it, and I'm seeing that this is a scatter plot. So I'm going to just make an amazing leap of faith. You should too. And decide that it's going to probably be called hex bin. Look at that, it is. Okay, that is it's called hex bin because it's a hexagonal grid, and it's doing binning. So it's essentially a 2D histogram with hexagonally shaped bins. And this gives you a color bar for the first time. because the color bar is going to report that in this particular bin, is that Hawaii? I don't know. There were 396 earthquakes. Here in Alaska, there were 199. In other cases, there were 2, 1, 2, etc. Sorry. All right, and if you want to find all the things that are available, all I'm doing here is dot and then pressing tab. You can have an area plot, a bar, well, all this. These are your options. We will cover 2 or 3 of them, maybe 5 in this tutorial. There are tons more, don't worry about it. There's probably a type for it. There is not currently a pie chart because we're philosophically opposed to them, but everything else should be there. Okay, I was already demonstrating getting some ways of getting help through tab completion. You can also get detailed help using words by just saying hvPlot.help with any of the plot types. It probably accepts, it'll accept a lot of things you throw at it. And when in doubt, just throw something at it. Here's a string that means this type of plot. If you grab a handle to anything, you should be able to get help on it as well. Here, this particular plot type has certain parameters. Those come from the param library that I mentioned. And you can change the color, the size, etc. And it hints that it returns a HoloViews object, which is interesting. We'll get to that. It does not return a plot. All right. Okay, I said that we like to avoid plotting where you have to fiddle with a bunch of arbitrary settings, and we also want things to work for very large numbers of data, amounts of data. Those are in conflict because the more data you have, the worse overplotting is. Because if you just throw stuff on the screen, it gradually fills up the screen. I've heard that called the sea of red problem. The more data you have, oh, I have 5 data points, 5 little red spots. I have 10 red spots. I have 1,000,000 red spots. Oh, now you have a red screen, and it's totally useless. So the more data you have, the more overplotting is a problem, and that's where Data Shader came from. What if you design plotting tools for the infinite data case, where they got better the more data you had? It never gets worse. It's always better to have more data. It might get slower. You might need more memory, but it's always better. The result is going to be more accurate. You're approaching the more samples you have from distribution, you're approaching the true distribution better and better, and you're conveying it more and more clearly. That's Data Shader, and if we can enable Data Shader in hvPlot. So Data Shader is its whole library. You can use it all by itself. It doesn't depend on hvPlot. It doesn't depend on bokeh. It'll just render an image, but it's integrated into hvPlot. And if you call hvPlot on this small data set, you'll see the results look very different from the previous one. Just to remind you, this is a 2D bin histogram, a typical bin spacing that people use, and this is dots. But the same data as that small one, all we did is turn rasterize equals true on. What that means is what I showed you in the beginning about that shift traffic example that's turning data that is not rasterized. It's rasterizing it. That means to turn it into a grid. And a hex bin is a form of rasterization onto a hex grid. This is a rasterization onto a pixel grid that is the same pixel grid as your screen. And that's why there's so much more detail going on here, because things are not being grouped across space and they're not just being pounded on top of each other so you can't see anything. Every pixel on here is a count of the number of data points in that pixel. And it's done dynamically so that as you zoom in, like just I did with ship traffic, it'll round trip to the server, redraw, and so anytime you see something going on, you can always find out more and more about it. And you'll eventually see, usually you'll see these weird lines here that are discretizations that you never even knew were there. You see all sorts of patterns. You're like, why did they do that? Why are fares rounded to the nearest quarter in the taxi data set, et cetera? There's things like that. And you see this is just all of the data. You just see it. And you can work with it very naturally. And whenever you see something, you don't have to wonder about it. You just zoom in, like this thing. Was that Hawaii? I don't know. Kind of looks like the big island there. I don't know if you have any Hawaii residents here. Okay. Anyway, I should probably know that. To know if that's where things happen. I know they have volcanoes there, so I assume they have earthquakes. Oh, sorry, I confused something here. This was the small data set. But Data Shader, like I said, does better with larger data. So somehow I skipped to the larger data. This is 700,000 points. It should be 2.5 million. It could be 200 million, like in the shipping example. It can be 1 billion. All of it is rendered very quickly in Python using array-based processing at machine code speeds, powered by Numba, powered by all sorts of things you don't have to worry about. It just renders it, and then none of that drags down your web browser, because your web browser is great at displaying images. It's just an image, so it doesn't slow anything down. Yes?
Does this make use of GPUs?
It will. It takes a Pandas data frame, which is a CPU-based construction, but it'll also take a CuPy data frame or a cuDF Rapids data frame or a Dask data frame, so you can have a distributed collection of GPUs, and that'll work. There's a performance section on the datashader.org website that'll tell you all the combinations that are supported of type of plot and GPU, Dask, et cetera. Pretty much all the combinations that make any sense are supported, and there are a few that are marked, no one's ever asked for this or paid for this. We could also support this combination. But roughly speaking, everything works already. I'm on a Mac. CUDA does not support Macs, or Macs do not support CUDA due to a longstanding feud between Apple and NVIDIA. That's probably even worse nowadays. It's very irritating, so I can't use GPUs locally that much. So I'd rather work with local data than a very fast GPU that involves latency from the data center to my laptop. But if you're not on a Mac and you've got a good GPU, great. Go for it. Notice a couple of options we have here. One is this one. It's called CNorm. What this does is always make the plot look good. I'll just take that off, and so you'll see what I mean. It's a little complicated to explain. This is something we came up with. It's histogram equalization, which is something used from images. If you take just a photograph, a black and white photograph, and you run it through histogram equalization, you go, wow, that looks great. The reason it looks great is that it's maximizing the amount of information in that image that makes it onto your eyeballs and activates. I'm a visual scientist, so it activates your retina, goes all the way to your brain. It works. It's a high bandwidth way to use the perceptual machinery you've got. This screen can display a certain number of colors. Without it, look how many colors it's used. It looks like one, right? And that's because there are certain hotspots somewhere in the world where there are a lot of earthquakes all the time, and those drown everything out. I can't even see where it is. Looks like there's one. Looks like one in Hawaii, one in the U.S. somewhere. A little hotspot. There are 10,000 earthquakes in that one pixel. So everything, if you use a linear scale, which is the default for hvPlot, which it should be, very good default. Linear scales, yes, everybody understands linear. You will not understand your data, though, because data is almost never linear. And so it's all pooled right on this one color, and you see none of the structure. So instead of EQHist, we could have used log, and that would work pretty well. This is log mapping. If log works, great, go for it. EQHist does not assume your data is log distributed. It does not assume it's linear distributed. It does not assume anything. It's fully non-parametric. It just, whatever the distribution is, it maps it into what's on the screen. So you'll see the color bar goes in log scale here. If I change this to EQHist, you'll see the color bar now becomes super weird. 1, 1.5, there's a 1, 1.8, 2.8, 5, 8, 15, 30, 78, 27,713. The reason for this weird color bar is that there are very few events at that level. And so essentially this is like a percentile plot. Each color represents the same percentage of the data samples. The top color is the top 1% of samples. If there were 100 colors, there are really 256. But imagine there were 100 colors. The top color would be the top 1%. The next color would be the next 1%, and so on. And so that's essentially what's happening here, is it's statistically breaking down all the different counts per pixel and using all of the available colors so that you can see everything. Now, what you can't see is which ones were the highest color. There are actually techniques you can use with this to label those in red if you want. Find all the ones that are in the top 2%, color those red, or put a big circle around all of those. You can pull those out explicitly. That's Data Shader. Data Shader is great when you're really working with data like this. We will not get into any of that. We just turn on EQHist, and immediately you see there's a ton of structure in the occurrence of earthquakes, and you ask questions. You don't publish this probably. You probably will publish it with the log, because then people will look at your color bar and they'll say, oh, that's normal. And it looks pretty good, it's fine. But it assumes that your data is log distributed, and if it is not, and it roughly is here, but if it's not, you will completely fail to convey the properties of the data. Because if it were linear, this would be a very bad choice, because now everything's going to be bunched up in the other side of the color range. Anyway, that was a digression based on how Data Shader works. We've done a lot of thinking about large data sets. All you have to do is turn on rasterize, see that your plot is ugly, and then add this. So you'll turn it on. You'll see, oh, wait a minute. Why does that look dim? Dim. What did Jim say to do? Okay, Jim said to turn on the magic of EQHist. And I'm going to misspell it. I think there's an underscore in it. I hope it'll tell you. Oh, good. This is a key thing for you. If you ignore all of this, this is what you want. This is the gold. Misspell it. You don't know the answer, just write anything. It'll tell you what's accepted. Linear log EQHist. Okay, with an underscore. Got it. So when in doubt, just put anything down, and it'll, for a value of anything, and then you'll get the right answer. Oh, and it's got this other tricky thing here. When you zoom in, like let's zoom into our area. Looks like there are earthquakes around here. If I zoom in a whole lot, eventually what you should see is that the pixels become visible. What has happened here is this is called dynamic spreading. Essentially, every dot has now been replaced with a circle. When you're zoomed out, dynamically, there's no spreading. It's a binning per pixel. But when you've only got 4 image pixels, if you set dyne spread equals false, when you zoom in, that's the default. Watch what happens when you zoom in. I don't know how good your vision is. There are little dots in there, but it's accurate, it's right. It's telling you the counts per pixel. There are not that many events once I've zoomed in enough, and you'll, if you can see them from the back, there's an event here. If I can hit it, if I hit exactly that pixel, I could find the event, but it's almost invisible. So we have this thing that dynamically checks how many pixels are activated, and are those next to other pixels, such that if you enlarge them, they would destroy those other pixels. If things are separated from each other, it dynamically increases their size. So it's pretty simple. So you can normally just leave it on, and it really helps when you're exploring data and you want to switch to, am I looking at the distribution? I'm still looking at the distribution. Still looking at the distribution. At some point, I want to look at individual data points, and then it should kick in. Okay, individual data points. Hopefully that makes sense. So it's a little bit of a lie to say that the results here are a 2D histogram. It's a 2D histogram until you get to the point where you now have isolated data points, at which case it reverts to a standard scatter plot. But it should do that switch at a point, and there's a threshold you can set for that switch. It's meant to do that switch at a point where you don't have massive overplotting, so that you're not using a circle this big when everything's on the screen. There's a separate option called spread I don't even know if it's supported in hvPlot, with just always spreads. You probably want dyn spread. So I've been to 3 in-person conferences this year, and by day 2 on every single conference, I've started to lose my voice. I think that's because since COVID, we've reverted to speaking in family units, and then I go all day talking to lots of people, animated outs, and then my voice goes away. Sorry about that. At some point, if it gives out, I'll have to have Andrew take over. All right. The point here is to try to make the plotting library disappear into the background. Notice that we used a standard API. We don't want you to learn lots of new API. Just use whatever you already know, hopefully. Or if you don't know this, learn it. It's not just for me or for our tools. It's for matplotlib, for Xarray, Pandas. Just learn it. It's pretty straightforward. It's not the most elegant API. It's a flat API. It's got one call and a bunch of options for everything. So everything is all in one namespace. If you're an object-oriented fan, you're going to look for some structure. No. It's a flat namespace with everything jammed in. But it's very convenient. You don't have to ask what structure to use. You just pile everything in, and hopefully it works. It's a really pragmatic API, the .plot API. So you don't have to learn that just for hvPlot. And then all you have to learn to get this additional features, to get this additional functionality, is to turn rasterize on, and then immediately you'll also want to turn this on, which we don't have as a default because, as you can see, it's super, super weird in trying to explain what the progression of colors are. And so you probably don't want to publish with it. We don't want to have it as a default, but you're going to want it for any new data set. And so we don't make these a default. I kind of wish that we did, because those are the things you normally are going to want for any large data set. Okay, next exercise is to do work on the original Pandas data frame, and then just see how that works. Because again, these are supposed to be going into the background, these tools. The real API you care about is Pandas API, or if you're an Xarray user, it's Xarray API. Those are what we think your brain ought to be on, because that allows you to directly manipulate the properties of your data. So here, let's go ahead and start doing the working with the underlying data frame. So here, we'll paste that in. So select a subset of the data. Magnitudes. Magnitudes. People probably cut and paste that in there and it doesn't work. All right, so how many people, anyone have a suggestion for what I type here to select, not that, to select the magnitude is greater than 5? 2 brackets, 1 bracket? 1 bracket, df, I think it's called mag. No, it's df.mag. I'm just going rogue here. Wait a minute, oops. Oh, that actually worked. So checking the magnitude is, in fact, greater than 5. Okay, success. This is not part of the tutorial. It's just like how to use Pandas and plot them with a different color map. Okay. I luckily don't remember what's in the solution, so I'm actually doing this as you watch. I am mostly a manager. I don't do that much coding anymore. I mean, I do a little coding every day, but I don't do all-day coding like people on my team do. Different color map. CMap equals reds. Okay, that seemed to work. Look at me go. Whoa. It's almost exactly. And I probably wrote this solution like a long time ago. So looks like my brain still works. Okay, is that clear? we're expecting you to do the bulk of your work here before you call hvPlot, and then hopefully you can mostly just use the same invocation here, because like I said, you're trying to have things that don't depend on the data, that you don't have to fiddle with. So there's no alpha parameter, there's no numeric knob you're trying to do. It just shows all of them, and if you change this number, you don't have to adjust some other thing about the plot. You should also get a nice plot. Another nice plot. If we do it with 7, like how many magnitude over 7 are there? Oh, look, now we got automatic spreading. Now you can see individual data points because there aren't that many over 7. Notice that I didn't change anything about the plot. I didn't have to. I used all the automatic stuff. That's what you should do. Use the automatic stuff, because then if you change something, you don't want to have your data disappear because you didn't make the corresponding data change on your plot. Look, it's even bigger now because there are even fewer data points. A couple of them overlap. You'll see that they got darker. At that spot, there are 2 that overlapped. And then everywhere else, there's 1. Okay? So this is how we think you ought to work. This is what we're saying as advice. Do your work at the API level. Learn your data API, whatever your preferred one is, which will depend on the field. If your data is columnar, you should be using Pandas or something like it, like polars or a Dask columnar data frame. If you're working with stacks of ND data, you should be using Xarray. Yeah, there's also cubed. There are other things too. Cubed is not supported here yet. It'd be great to support that. If you're using awkward data, you can use awkward array, medium support for that. Actually, I don't know the status of the awkward array support at all. But in any case, learn your data API, really come to terms with your data at the API level. Let your plotting just follow along and show you whatever is actually in your data. Okay, before we break here at the end of this notebook, let's just quickly show you other types of plots. Here we're, again, reverting to matplotlib to show a histogram. So matplotlib will happily, I probably need to start at the top here. Matplotlib will happily show you plots. Instead, let's do a similar plot. Actually, I don't know why that's not showing up here, the matplotlib one. Anyway, I don't need it for the point. The point is, if you use hvPlot, you'll also get histograms, and now you get hover information and zoom and so on. The zoom is not always great. Like, that's what happens when you zoom on a histogram. Like, why does it leave the axis? It's natural, that's what zoom does, but I don't want that to happen. I would only want zoom to work in the Y dimension. There's a lot of things about the automatic interactivity that are just annoying that I would wish we could improve, or we will someday improve. Okay, you can use a histogram, but let's try another type of plot. Kernel density estimate. So, like I said before, make a big guess here, or you can use the tab. K, is there a kernel density estimate? There is, look at that. So instead of hist, use KDE. It'll probably complain because some of those, yeah, I'm glad it complained. Some of the parameters I typed in are not relevant to a KDE. It's some of the same data as in a histogram, but it's computed a very different way that's not binned like that. So there's no bins. Get rid of those. That's better. Okay, that's basically a smooth approximation that's meant to indicate what the underlying distribution is, subject to a whole lot of assumptions. That type of plot. We've only looked at numerical examples, but we can show categorical example. In this case, what we did is take something that already worked, and then we added a keyword called by. This is a powerful thing with hvPlot. The by keyword will give you a categorical legend. You can't really see the stuff. Okay, so the legend is live, so you can highlight things. you can see that there are not very many deep events. We created this categorical value by taking the depth and discretizing it into 3 categories. You can, again, that's all done at the Pandas level, so I didn't even talk about it. That's where you should be doing things. But once you have that, then you can do a type of group by. It's in this case, it's a color by depth class, and it gives you a legend, and you can see how everything relates to each other. And here there's an alpha, and that's for the same reason as always when you use an alpha is otherwise things overplot each other, and you have to turn them off to be able to see anything. Luckily, the tool automatically does this alpha here. Anyway, there's no data shader for a bar plot like that, so I apologize. There still is a parameter for that. I don't know that data shader would even mean anything there. Okay, we're just doing a quick tour for other types of plots just to reassure you that there are other types of plots, and because we're going to use some of these later. So let's see, if we did by, but now instead we do subplots equals true. It wants me to do a different width. I don't know why. Okay, it wants a different width so it'll fit on the screen. There's also, you can also set a responsive width, so it just always fits in, but it says do it by 300, so I did. Okay, so here it's grouping it by depth class, but instead of by default using that on the color axis, it's saying, no, I don't want it on the color axis, I want it on as subplots, or small multiples, this is also called. And you can get, essentially this is binning, this is 3 bins. The data has been binned across an invisible axis, the depth class, and then spread out in these 3 plots. And so this is where hvPlot really, really shines, is when you have, normally when you measure data, you can measure, do you just measure one thing? You might. I mean, you might say, I measured the temperature outside and whether I felt hot. Like there could be one thing you measured, but often there are many things you measured. So you have many columns in your data frame or many stacks of many dimensions in your multidimensional data set. And your screen still only has 2 dimensions, X and Y, and then adds color as another dimension. And in this case, we can use space as another other dimension. There are a finite number of dimensions. I had one plot for my PhD where I think I got 15 dimensions into one plot. But that's a lot, and there's still way more dimensions than you can handle. And that's where hvPlot is really good, about being flexible and letting you figure out how to map the massive number of dimensions you probably have with all your measurements onto the minimal, paltry number of dimensions you can actually fit on the screen. So do I want to use color for this? Well, color is great, except for colorblind people. Also, our color perception is highly nonlinear. I don't know. If there are only 3 categories, yes. If there are 50 categories, ugh. If there are 500 categories, no. We use a tool called ColorSet, or created a tool called ColorSet that lets you use different colors for like hundreds of different categories. In practice, you probably can't do it. So sometimes you can map things onto color, and that's great, because then you can have one big plot and it's all in one. Like on the ship traffic example, we've mapped the category of the ship onto a finite number of colors. In that example, though, there were actually 100 of categories or so. I binned them, saying all cargo vessels, I'm going to label them all red, no matter what type of cargo it is. It's just cargo. And that way I could distinguish. You saw the pictures. They were beautiful because they were clearly separating the behaviors of different classes of ship. Now, that was a choice that I made when deciding how to see this data. That's where these tools are really useful. You've got so much data, and you've got to really work. How do I bring it to the screen? How do I convey it to other people without fooling myself about its properties, without getting misled? How do I just dump it on the screen, and then how, once I've dumped it and I understand it, how can I convey it to other people? You can easily switch between small multiples, between using color, between overlaying things, laying them out next to each other, slicing and dicing. I guess the next example is an even better example for that. Here, instead of using by, we use group by. The only difference is instead of doing that by color, group by will by default give you a widget. And so you get That way you can still have a big plot, but you don't see it all at once by color. Instead, you see it one by one. And this widget came automatically, and this is great, because if you have so many dimensions, at any moment, I don't know whether to look at that. Don't worry about it. Just put a widget for it. And there's one widget here. You can do lots of widgets. You can have, I guess this would be a list in that case. I don't use, hvPlot is an old library, but it's still a lot newer than when I was doing things. My brain is still hardwired to HoloView's syntax, so I know how to do it there. But you should be able to group by lots of different things. And so you should be able to say, these are the dimensions. You can use it to aggregate across your dimensions, select across your dimensions, spread them out in time, space, everything, color. That's why it exists. It exists because the basic plotting tool doesn't handle that. But data sets are like that. As a scientist, that's what we're always dealing with. We measured all these things. And so this is a tool designed you to quickly get those onto your screen and into your eyeballs and let you work with that data naturally and reasonable. That's why it's powerful. That's why we don't just use .plot. We use this, because all these things you can do with your data. Like I said, we're built on everything. So you'll see this warning message. Every time Pandas has a new release, they change some API. It looks like they changed that. We had a fix right before the tutorial. It had fixed it in some cases, but not in this one, we found out later. That's the downside of being in a super connected ecosystem. We don't control everything in the universe. Things will break. That's where Anaconda project comes in. It'll pin to exactly the version. We decided to pin to this version because actually Pandas improved some other things. So we decided, in balance, this is better. And so this is only a warning. The things that it improved were errors. So anyway, apologies. You have to look at the error message, and that'll go away as soon as we update HoloViews to use the new way of doing it in Pandas. We've seen many versions of Pandas. We always adapt to them. It's okay. Pandas will break things for us. Dask will break things for us. Numba will break things for us. Matplotlib will break things. Bokeh will break things. Mostly, those are the biggest breakers. Anyway, here's a heat map example. Data shader is basically a heat map, but when the bins are shrunk down to 1 pixel. And you can actually make data shader use this size a pixel too, but by default it figures out the resolution of your screen and does it uses that for the bin size. And so that's max. Like here, you're throwing away so much data. What if there's some cool different things happening over here? You don't know because you threw it all away by binning it really coarsely. It's typically how people do heat maps. We don't believe in that. We say, just show all of your data. If you need to bin it for some reason that you have really poor sampling and you don't want to make claims about it, fine. But by default, show all your data. Anyway, I can't remember why it's showing you this plot. Probably just to show a heat map. All right, and I've alluded to the fact that these are bokeh plots, but we also support other things. You can easily select Plotly or Matplotlib output. This particular one, here's an we now made Plotly the default. So if you just ask for a plot, you'll get a Plotly plot instead of bokeh plot. These tools were written before bokeh. Bokeh is old. Bokeh is 2012 or something. We've been writing these tools since before that. So we added support for bokeh. At some point, we added support for Plotly. We always had support for Matplotlib. You can choose whichever one you want. You will be able to see some of the history. Matplotlib has had lots of development on our back end at some point, but when we switched to really doing interactive work, we've mainly focused on bokeh because the people who worked on bokeh were in the next office over for me. And so it was great. You can make things happen. Now they're at NVIDIA. We do have a bokeh developer on our staff. But anyway, we use Plotly for some things. You can also choose at any moment, you can switch, and here we'll choose to have the same call result in a Matplotlib. And for any of the arguments you pass in here, it should really not matter. Now, there are other ways to customize plots, and it does matter. You can get at the Matplotlib specific options, the bokeh specific options. You can get to them, but the basic normal options are the same across backends. If you need to get publication quality output, that's a lot of the reason why people use the Matplotlib backend, because they're not trying to make a web app. They're ready to publish it. then you could get, for instance, convert it to an SVG, and that this is now an SVG. And now paste that into something and go ahead and publish that. And you can edit all the detailed matplotlib options to make exactly the formatting nature requires or whatever. That's all lower level stuff that you can get to. You can even do the matplotlib supports the XKCD setup. You can use that if you want. That's done at the rendering stage. So just as background, when you get something back from hvPlot, you get an object that when it's in Jupyter displays itself. That step is called rendering, and only then do you invoke the bokeh, matplotlib, or plotly. And so up to that point, you can doctor it. At that point, you can get a hold of the matplotlib figure, and you can further doctor that. You really want to mess with the matplotlib fig, go for it. Do whatever you want, like in this case. And then, so it's fully customizable. You're going to have to do more and more work the more you want to deep dive into it. It's designed to make the easy case trivial and for you to spend as much time there as possible. I think the last bit of this notebook is that if you if you follow our hints, everything is easy in here. What if you have no idea what you want? We provide a tool. I think Andrew, wherever he is, was doing a lot of work on this called the Explorer. You can just feed it anything, a data frame, an Xarray data set. He added a lot of support for Xarray. He's an atmospheric scientist. And then you get to choose whatever you want. So in this case, it's just dumping everything. This is all the columns of the data set arranged along the index. It's got a time-based index, so it's just dumping everything. That's probably not very useful, but it's a useful tool to figure out what you do want. So if you want to select time versus depth to see have things been going deeper over time, which would be crazy, right? No, they don't seem to have been. And then you can get a hold of the settings that you chose interactively, like you set various styles about it, whatever you want. I don't know, this is not going to have an effect, but anyway, you fiddle with it, you make the plot you want, and then you can grab those either as code or as a dictionary of settings, and then you can delete the Explorer, and then you've got that particular plot. So it's a good way, especially as you're starting to use it, or if you encounter an unusual data set. I don't know what's in there. You just try it out and see what's going on. So highly recommended as an exploratory tool. Okay. This is basics for hvPlot. It's supposed to cover the fundamental principles, why it exists, why it's valuable, what it's useful for. I hope that's what you got out of this. I'm going to take a break and let my voice recover for, let's say, 10 minutes. There should still be coffee out there, should be other beverages. There probably won't be food anymore. And 10 minutes would mean be back here at 9:40, and we'll launch right into the next thing. And the next thing, there'll be one notebook, and then there'll be exercise where you're all doing your own work. And while you're still here, does anyone have any issue that they need someone to help them with? Talk to Andrew or wave me over. Thank you. All right, we're back. Somebody pointed out on the chat that we should be using the magma color map when we're looking at earthquake data, and you're right. That was a missed opportunity there. All right, now we're going to actually see some of the magic or understand how some of this works and dive into why you would care about that and how that's going to change things. So we're going to use the same data set. We're going to use the same data set for all of it. Or actually, there are a couple of data sets, but they're all always the same ones. But each content of each notebook is independent, so you can run in any order later. In this case, let me go ahead and clear the outputs just to avoid confusion. Okay, so let's read that file in. Let's go ahead and create a couple of different plots. Here's one where we've resampled time by week to bin across bin counts of events across the week. And then notice what just happened here. This basically normal Python happened, which should be surprising to you if you're used to matplotlib inline. Matplotlib inline was somebody trying to make matplotlib work with Jupyter in the very, very early days of Jupyter. Jupyter wasn't even Jupyter then; it was IPython, I believe, and it was. IPython had certain things, including magics. It was a way to make things work. But what happens with the matplotlib inline is that plots are a side effect. What happens with hvPlot is that plots are like any other Python object. If you return the value 2, it displays 2. Like nothing's returned in this cell. Like look, nothing is shown because nothing is returned by this cell. But if I wrote 12, it'd be returned as 12. If I wrote a string, it would return the string. hvPlot objects work exactly like that. They're just normal Python. There's no reason to do anything else now that Jupyter supports what's called rich display. Jupyter displays a string like that. Notice that these quote marks. It displays a string by default as the string in this font with those quote marks. But it has the support for making anything have a certain type of display. And we use that rich display support of Jupyter to display this object, which is an object of type from HoloViews, it turns out. It's a curve type. But when you display it in Jupyter, what do you get? You get a curve plot. You get a whole plot. Now, so what's happening here is it seems like it's weird and mysterious. It's not. It's exactly how everything else works. It's just surprising that it works like everything else. So anything that's returned, Jupyter has support for rich display, and it will not just display it as a stack of bytes. It has a mapping to find out how do I display something of HoloViews curve type. Oh, looks like that's going to become a bokeh plot. Look at that. That's a bokeh plot. So you can register how you want things to display, and we have registered that we want HoloViews plots to display by default as a bokeh plot. But we can also just grab a handle on it, and then it's not even displayed at all because there's no return value from the cell. Jupyter just assigning a variable assignment to an identifier doesn't result in an output in Jupyter. So that's weird thing to point out, number one, which is that it acts normally. Objects that are returned by hvPlot are just like any other Python object. Essentially, they're a data structure that is some data, some options. They're a little chunk of data and settings, and they look like a plot when you display them, but you can also work with them rather than just displaying them. So we can display it. We could instead print it. Oh, it has a string representation as well. This is the bokeh plot representation. What if you're on a terminal? This is probably as good as you're going to get. A string representation. It's a little weird syntax. This is very old, but at the time we decided it should have a colon. I really don't remember why. I think it's something to do with, I think I remember why, but it's complicated. and I don't want to misstate it. And what this is a curve element of graph of time, count versus time. And little brackets here tell you what the nature of each axis is. These brackets here are what we call key dimensions. These are dimensions, like there's a time dimension and there's a count dimension here. We come from a multidimensional background originally. We're neuroscientists, so we're used to thinking of things being sampled on a grid. And so we call them dimensions. You can call them columns in Pandas. You can call them variables if you're in certain fields of math. This is in this plot, this is an independent variable or a key dimension, and this is a dependent variable. At a given time, how many counts are observed? First pick your time, then you observe the other one. So they're different. Like if you swap these around, it'd be really weird, right? If you did the count for a given count, what time was that? That is not how people think, because you measured a time and you see, what did I measure? There's an independent one. You just chose when to measure that. You just picked it out of a hat. I'm going to measure today. And then what you measured is what you discovered. It's what you found out. That is a dependent variable. This is an independent variable. HoloViews knows the difference, and it knows that time is what's called key dimension, or an independent variable, if you're from that. It's also an index dimension. The same concept is across databases, math, computer science, everywhere. Everyone has the same concept. They all call different names. Unfortunately, we added a whole new name. Key is from database world, but we added the word dimension because we were from, anyway, we call it key dimensions, sorry, or KDIMs. And then this particular plot has one key dimension and one value dimension, or also known as the dependent variable, or not the index, but the value of the lookup, if you're from a database background. You can have any of each that you want. If you're on a geographic plot, it'll have two key dimensions usually, latitude and longitude. Neither one of those is dependent on the other. You don't go pick a longitude and then see what your latitude is. That doesn't make any sense. Those are both key dimensions. So if this were a geographic plot, this would be a key dimension and this would also be a key dimension. I'm sorry it's tedious, it's just reality. Most people can ignore it. The high-level types of things that you do in HoloViews, you can't ignore it, because certain things make sense for key dimensions. Certain ways of indexing and selecting don't make sense if they're not key dimensions, because you can't just pull out the highest counts. That's a filter rather than an index. You can do it, but you shouldn't be doing it the same way because it means something different. That's a filter on your data rather than a choosing what data you want. Anyway, this notation shows all that. And you'll see here's another one. It looks like the same thing. Okay, that's just by magnitude. All right, so we'll come back to these notations at some point. When you'll see other examples where there's multiple key dimensions or multiple value dimensions. You can have as many value dimensions as you want. You could have 50 in here. They would all show up in the hover, let's say. Right now, only one dimension shows up here. But even if your plot doesn't have it, you can just throw everything else in there. Everything, like 50, 100 dimensions. You'll get a hover that's 100 dimensions long, and you'll see all the other stuff about that data point that didn't fit in the plot. So as many value dimensions as you want. The key dimensions kind of define what kind of plot it is, though. You chose what goes on the axis, and if you have a dependent variable, you chose that goes on to Y. There might be many dependent variables. You decide one of them to put there. You can put another into a widget with group by. You can put another into color with by. You can do anything you want with all sorts of dimensions. HoloViews needs to track which ones are which, or hvPlot does. All right, so now we're going to finally make use of the fact that these were objects, because we're going to do some ridiculous thing with it. We're going to multiply them together. This object, which was a plot, times this object, which is also a plot, equals this plot, which is an overlay. It turns out that multiplication semantics are roughly mapped to overlay. and plus semantics are multiply mapped to laying out side by side. That's what we chose. It actually makes sense. The way that the ordering of operations works, it's reasonable, it's concise. You don't like it? Well, you could say overlay, hvPlot.overlay this thing, comma, this thing. You could do that. But you do this all the time. We put a very concise syntax. So this thing, which was visible on its own, was a plot, but it wasn't a plot, it was an object. And the reason you can tell it's an object is that if you combine it with another object, you get a new object. Whereas if these were two different plots and you overlaid them, they would just all be like fighting each other with multiple things on the y-axis. They're not fighting each other because they were combined in an overlay and that thing was plotted, not the individual things plotted and then combined. That make sense? The plotting happens as the very last step right before it goes to your eyeballs. And because we delay that as much as possible, you get power like this, that you can combine them, or you can put them next to each other. You can do all sorts of things with them. This is only... yeah, I just added this. It's total hack because I've not explained anything to do with it, but I had the same question when I went over this yesterday. It's like, okay, I know I'm cheating, but I'm going to go ahead and put that in there anyway. So yes, you can have any number of axes. The rest of them are just going to stack off to one side if you have more than two. But yeah, it could be, this is only recently supported. It could be the default. You should automatically get multiple axes if they're incommensurate, if they're different dimensions. If one plotting a count and the other one's counting a magnitude, and you know count, magnitude, those are not the same thing. For historical reasons, a lot of plots would break because you would have, historically, we might have 10 things overlaid and people only relabeled the first one because that looks the same in the plot. We've got 10 years worth of usage like that. So you have to explicitly enable this, but when you enable it, it doesn't have any effect except if they're multiple. It just means it will respect the fact that they have different y dimensions and give you as many axes as there are unique dimensions on the y-axis. So there could be 50 things, all of the same units, all the same name, that will not make a multiple y-axis. It's only if one or two of them or 50 have different things they're plotting, then you get another axis, and then you get a legend. Okay, and the reason it's cheating is that it uses this syntax, which I have not explained yet. But I thought this would come up. It did come up for me, so I snuck it in there. This is how you change things on the object that you've got. So here, this is an overlay object. It's an overlay of two curves. And you can still mess with all the options before it's displayed. You can do all sorts of things. You can stack and put complicated buckets of things and still mess with everything all the way down using this mechanism. I will not explain it till later. Okay. Keep doing more cool stuff with it. Let's see. Here's a pulling out the most severe ones of matplotlib originally. Yeah, that could have been this is Viridis, I think. It should be Magma. We do the same thing with hvPlot. Shouldn't be anything exciting and different. And then, oh, okay, there's something here, though. Here's the first case of seeing that there are multiple value dimensions. And this is going to be a problem because this is showing, I hope I'm about to explain this. Oh, okay, yes, good. Because this is not right. This representation shows you that this object purports to have a longitude key dimension and two value dimensions, latitude and mag. So you chose a longitude and then you discovered a latitude and you measured a magnitude. Ah! That is not right at all. It looks right, but it's totally wrong. And you're going to make weird errors later on. I'll show you one example in the exercise of why it goes wrong. You can get away with it. You can publish this. No one will know. But it is wrong. And that's because scatter takes one key dimension, and it assumes the other dimension is a scatter around that. So if you measure on made 5 measurements that day, you're going to get a scatter, like literally a scattering of various points around that key dimension value. That's what a scatter plot is you did it 10 times, you got 10 points. That's why it's called a scatter. But you don't want a scatter here. You actually want a points plot. And we have a different name for that. Matplotlib does not, because it doesn't allow for the types of interactivity where it would matter. So scatter versus points plot doesn't matter. It does matter for hollow views. It does matter for hvPlot in only very subtle ways that'll bite you if you don't do it right. And it's hard to remember when those are, for me even. It's just do it right. And so you need to somehow get this guy into there. Why is it in the wrong one? Well, that's because the default is that a scatter plot only has 1 key dimension. So instead, let's use something that looks identical, which is a points plot. And a points plot will have the same visual representation, but the different string representation. Where was I? All right, looks the same. There we go. A points plot has 2. It does not distinguish between the 2 key dimensions. Like anything spatial, it's going to have 2, or if it's 3-dimensional spatial, has 3 equivalent dimensions. They're really latitude and longitude. Neither one is subservient to the other. They're just an arbitrary choice of axes that you put on it, and together that's your key dimensions. The pair of that is a coordinates. Or if it's 3-dimension, a 3D triple is your coordinates. That's your key. Everything else is a lookup. So your key, in this case, should have been latitude and longitude, and at that latitude and longitude you measured a certain magnitude. This is correct. Unfortunately, I don't have an example here showing why it matters, but we'll have that in the exercise. The name. Points instead of scatter. Yes?
With the scatter then, is it, I guess I'm just trying to understand why it has that behavior. Like, is it treating one of the axes as, like, always categorical then, basically?
Not categorical, but if you, for instance, what we'll have in the exercise, if you do a selection, by default on a scatter, the selection should only be on the key dimensions. So it'll be a selection based on longitude only, which will be the wrong behavior because you want them to be equivalent. Instead, when you do a selection on this plot, it doesn't have a select tool. So that's the way I could illustrate it, by adding the select tool. Select tool in this case should be a box because it's selecting a region in 2D space. The select tool on this one should not be a box, it should be a vertical bar because you select the key dimension and you observe the other dimensions.
It's just assuming one of these independent variables.
Exactly. So you independently choose the independent variable. It's independent. So when you're making a selection, that's a choice of the independent variable or the key. And so by default, you can mess with it, but by default it should be key dimensions only when you're making a selection. And there are various other, like, oh, that's where it matters. Oh, that's where it matters. There's subtle things to do with interactivity. This is just saying you're going to hit one of those at some point if you don't do it right. So think about it. What are the key dimensions? What are the things that were setting up the conditions for the measurement? And what were the things I observed? And that's the boundary between your key dimensions and your value dimensions. All right, we're going to work up to some more complicated plots where we're combining data. So usually the default color map is totally fine, but when you start combining multiple things, now you have to start worrying about color maps. So is everything going to be blue? Uh-oh. So you need to choose like some warm colors and some cool colors. Then you can combine them and you can keep them straight. So in this case, and if you're going to overlay on something like a map, you want to have colors that go with a dark background because the map has a lot of dark elements in it often. And so you want bright colors. So in this case, we're going to switch to a black background with a bright color map. In this color map, it started with black and went up, but we want all the points to be visible. So we took half the color map. That's right here. Well, a little more than half, a little less than half. It's 256 colors. We took we dropped the bottom 100 of those. So we took the top 156. And so if you change that, you'd see that here's the original color map. We only took the top part of it. and that's because we choose a black background, and we don't want things, in this case, we're going to plot a bunch of severe earthquakes, so they're all going to be up here in a normal color range, and we want to preserve that. We just want to get rid of all the lower ones and make them go to 0. So here we're going to say, we're only going to take from here onwards, well, from, I guess, here onwards, that's the color map we're going to select, and it looks like that. So we select that, and that works well, so you can see individual data points against a black background, but you can still see the most, the highest overlapping ones where there are lots of them. You can see those are different, but you can see them both. So this is the sort of thing you have to do when you start combining things, because you're trying to cram as much data into that as you need to tell your story, which is what we're trying to do here. All right, and we just double check the representation. Yes. I don't know what I did, but the key dimensions are correct. And then it looks like there are 3 value dimensions, of which one is mapped onto color. So color is the magnitude, so that's this scale here. And then the other 2, I told it to use that in the hover. I mentioned this earlier, but you can see the result of it. Place and time are not in the plot. In fact, how would you put place in the plot? It doesn't have any meaning, but you can put it in the hover. Arbitrary strings can go in the hover, like place. It tells you in words where this thing is. And in this case, it tells you a distance from some inhabited area. So it's trying to tell you how close was this earthquake to somewhere that people would care about. And so like here, this is Mexico. Okay. See if we can find one. That's California, Canada. Ah, there's nothing severe in this area. That's good. Glad to hear it. So those are the 3. It's my daughter. I'm busy. All right. So so we chose 2 key dimensions, 1 value dimension, and an additional 2 value dimensions that only show up in the hover. So in this case, that's 5 dimensions. We show 3 directly, 2 implicitly based on location, 1 explicitly with a color bar, and 2 with hover information. And that's exactly what you'll do all the time when you look at your data. Like, okay, what do I put on the axes? Do I use color or not? If so, what do I use it for? Do I have small multiples or not? If so, what for? Do I bin things to make it categorical or leave them discrete? If it's discrete, you might end up with a slider. If it's categorical, you might end up with a drop down, and so on. Those are the things you have to do because you have so many dimensions, and you've got to put it onto your paltry little screen. Okay, I'll mostly skip this, but this is just showing off the color set library. Did I skip that one? Probably. I have no idea where that. Oh, I remembered where it went. This was a long time ago I wrote color set. This will just show you a lot of color map options. These are what are called linear color maps. So they map from a range of numbers into a range of colors continuously. So they're linear. In fact, they're perceptually linear so that as you move left to right, each color should occupy the same space in your brain so that you don't see big patches of the same color here. Anyway, you can go to color set and see all that if you want. Meanwhile, they're just a collection of perceptually okay, well done, things like Magma or Viridis, the same ideas there about choosing a good color map that accurately represents the data. You can choose whatever you want. And often, you'll have your own favorite color map that you like to use. And then when you're trying to combine a bunch of things, you need to have a stable of things you're trying to do. Often in your field, there might be some cool things and some warm things. That's a very good approach. I've combined cool and warm, and you choose which one is cool and which one is warm, which will be a little subtle about how what you want to convey about the things. Anyway, you'll get some typical ways of doing things, but you can, if you don't want cool and warm, you can have the red and green and the blue. That's another. If you have 3 things you want to distinguish, 4 with yellow. The more you try to do with color, the more problems you're going to have with colorblind people. There are some colorblind safe color maps in there. Anyway, it's just letting you know that you can choose whatever you want. And I said that what we were going to get to is that when you start to have something in the background, then you have lots of trouble because look, sometimes the background is white over the poles, and sometimes it's dark. So if you choose one particular color, sometimes, like if you choose yellow, it's going to show up great over here, very poorly over Greenland. Mostly your plots are not going to have a lot of data in Antarctica unless you're an Antarctic researcher. And if they do, well, you should probably just set alpha on this tile to make it all kind of dark so that even Antarctica is kind of dark. You make that dark, and then your data point's light, and you're in good shape, right? So anyway, you pick a background, and then you'll pick some things to show in front of the background. Here, we're using that color map we created earlier to show the most severe earthquakes. And then we chose, this color map was chosen deliberately. You remember earlier I showed it with a black background. That's because I was expecting to put it over this map background later. And you'll notice that I don't happen to be in Greenland, so I'm safe. But what you want is a color map where the lowest value is similar to your background. The highest value is as most dissimilar to your background. This is a basic principle. If you're overlaying something on top of each other, the data you're overlaying, when it's weak, should blend into the background. When it's strong, should be very different from the background. If you reverse this, your results are super misleading. They might look pretty, but they're wrong. Like if we reverse it, it's just a list, so you can use list syntax. In Bokeh, they're lists, in Matplotlib, they're objects. But here, we just reverse this color map. Now yellow's on the bottom. This looks great because, well, you can see all those points. But it's super misleading because the highest values are now the ones with the low that go back into the background the most. So if you look here, this data point right there should be standing out because that's the highest the highest magnitude. But it actually is the one that is the most similar to the background and the least likely for you to notice compared to this one that is the lowest magnitude. So this is wrong and backwards. Don't do that. Choose.
It's whatever's most important. You want to be standing out the most.
I don't know about it most important, but if it's a numerical quantity, the one importance or strength or magnitude or count, whatever the data points that is the most data-ish. Yes, that is the thing that should have the top of the color map, and the top of the color map should be as different from your background as possible. If you're gonna draw the eye to something, don't use this technique to draw it to the things that you are making money on, unless you're cheating. Draw it to the things that are real about the data. The way to do the real about the data is following what I just said. Make sure the highest value are the ones that stand out the most from the background. So in this plot, what stands out? Well, that point stands out to me because it's the most different from all these run-of-the-mill 7s that are everywhere. Oh my God, there was a 9. That's a big deal. And I spotted it. Just glance at this. You just walk up to this plot. You can say, oh, what's that? That's an 8.3. Oh my God. What's that? Hard to tell. You have to zoom in, but you can figure out 8.2. What I just modeled for you there is what you should try to achieve. That when you make a plot, you make the things that are real and true stand out the most from the background. And I chose to have this plot background. Therefore, I must also, it's incumbent upon me to choose a color map where this is more similar to the background and this is more dissimilar to the background. Otherwise, you're misleading your users. So that's my color set maintainer hat on. I'll put that off. I have very strong opinions about color maps, which lots of people do. Anyway, I have such opinions that I made the whole library. All right, exercise time. And I kind of didn't explain this. If you're not in geoscience, surely you've used Google Maps. The way this background works is called a tile map library. If you zoom in, it's just like Data Shader, except that it's not dynamically computing. Data Shader is totally dynamic. Data Shader, there's no magic pre-computed tiles in the background for Data Shader. You zoom in, it starts fresh, it doesn't know anything ever happened. It goes through all your data and renders it on the fly. The similar things happen with web tile sources like this, but instead of dynamically computing it, you just swap in this one you made earlier. And so they pre-render the entire Earth at low res, at medium res, at higher res, at high res, all the way down to street level in Google Maps. This is tiles from Esri. If at some point they will stop increasing, but as you zoom in, it's higher resolution. At some point it'll just turn to nothing. It doesn't go any further than that. So this is often it's very handy just to be able to, if it's geographic data, just throw in tiles in the background. It's so handy that we just make it be as simple as this. Probably that's what you'd get if tiles equals true. You don't have to remember that. I think that's what it does. Anyway, if showing data in context is a very good idea. If it happens to be on the Earth, show the Earth. But it doesn't matter that this is on the Earth. If this were arbitrary, some quantity versus some other quantity, the plot would be the same. It would just delete that.
What if your style is specific for the Earth,
Yes,
but points is completely unique?
that's right.
You want to show something
That's right. So
somewhat background.
did we show the population in here? Or was that? No. Okay, well, you can show anything you want here, and that's what the star operator does. You can just do something on top of anything. So you have some points, you have some other rendering of any sort of context, which might be some underlying data space that you can show the population, and then some samples from your latest study. You can show the latest study in the context of the everything before. That's what the star operator is great for, showing data in context. In this case, we didn't even use the star operator. We totally could have. We could have separately plotted the data and then starred it, overlaid it with a separate tiles object. We had a tiles object here. So yeah, we can, instead of this, this is just a convenient syntax. If we take that off, we'll get no tiles, and then we overlay it. Overlaying goes left to right, so I want that in the background, so I put it at the left. It should be the same result. So the tiles is just a little sneaky, quick way, oh yeah, show that geographically without having to always type this. But the fact that it's tiles doesn't matter. The fact that it's something that can be overlaid with that does matter. And so you can show anything as the background. And we'll use the different things as the background later. There are lots of tiles available. We only support one in HoloViews, which is this web Mercator, same as Google Maps uses. If you want others, use our GeoViews library. It's built on the massive geoscience stack that's decades old. Decades old means it has tons of power, just like Matplotlib. Decades old, tons of power. Also, tons of cruft. It's been built up over years and years. It's harder to get the geoscience stack running than it is to get HoloViews running. So HoloViews gets the basic things that work. And if you want weird projections, have it on a spherical Earth, totally go for it. That's GeoViews. This is not a geoscience tutorial, but it's ready to do that if you want it. You can use different tiles. Actually, I have no idea what tile sources come into being. They get popular, and then people clamp down and say, oh, wait a minute, we're spending so much on bandwidth. No more. Now you have to register. We only use whatever's free, and so I don't even remember what's available. This is Esri. Let's try OSM, OpenStreetMap. Oh, I have to import it, which is another reason to do it as tiles. So if I do tiles, then I don't have to worry about importing it. Okay, tiles, OpenStreetMap. That way, if you zoom in, you'll get streets, I guess. As you can see, the data looks very different depending on what it's in front of. You have many choices on tile maps. So use what you like. Oh, here's what I was about to say. I thought there was an example recently. It's an example I'm about to get to of overlaying on things that are not tile sources. Here, this is something that looks like a tile source, but it's actually a plot of population. We'll study it a little more closely, but it's just Earth's population where X and Y are latitude and longitude, and it's a log axis. This is a rasterized data set. It's actually the output of Datashader from a while back. We didn't want to send you the location of every human in the world because that would slow down the Wi-Fi. Instead, we pre-rasterized that, and that's what we sent you instead. Binned it spatially. It looks the same, except that if you zoom in, you won't get down to individual people like you will with the original data that we have. Instead, you will zoom in, and you will eventually, you'll see that it updates, and at some point you bottom out into the resolution of the data. There's no more resolution. Doesn't matter how much you zoom in. It's just, that's the data. So it's been binned at this spatial resolution. So it is a Datashader plot without Datashader anymore. Datashader's not involved. You just have the data you've got, which is to render it at some resolution quite a bit larger than what's visible on the screen. So you can zoom in a little, but beyond that. And so if we overlay on this, we're not using a tile source. We're just using data. And this could be data from it could be the average of all studies you've ever done. And then you overlay in a warm color on top today's data. So you see everything in context. That's how you should use this functionality. This comes from Numba. Like I said, every time something happens, we've got to update. That's why it's important that we all have jobs. This is our job to update all of that. We're paid to do it. It's not, it is labor of love. It started as labor of love. We work every day. We come to work. This is what we do. And we see this, and we, okay. We figure out who it was, what library is involved. Do we need to change, or do they need to change? In this case, it's between us and Numba, about OpenMP, I believe. Okay, anyway, what you're seeing right there is illustrating how these work with Xarray. Here's instead of hvPlot.pandas, we installed the accessors on hvPlot.xarray. And there are lots of hvPlot.somethings. We're using Xarray here. And now we open an Xarray data set. This is a netcdf file, I guess. This is a multidimensional data set, not columnar. It's got one band, so it's pretty simple. It's basically an image, like a black and white image. It looks colorful, but it's essentially a monochromatic image, a single band with this resolution, and type float 32. So 3 axes, although one of them is degenerate, it only has one value. All right, and so we're going to take this. It's got some no data, the way that it's representing the absence of data. We just get rid of that, and because it didn't plot very well. And then we we declare a name, and then we can plot it. This is, again, the original .plot, so we're not using any weird syntax. We're just the same syntax you'd normally use with .plot. Oh, this is weird. It's because if you don't do that, you'll notice that that it doesn't work by return values. This is the return value of that statement. Oh, and you also get a plot. So this is the side effect nature I was talking about before. You end up getting this object back, but that object doesn't display as a plot. You get the object back, and you get the a plot, and you can't easily just grab that object and then display it separately, not in the same way. So that's why we put this little semicolon there, which is like, wait a minute, what? That's C. C uses semicolons. You don't need that in Python. Well, you do if you want to trick Jupyter into not displaying the output that's returned from this value. The value that's returned is the output of this cell. So that semicolon just is a hint. It's a special behavior because the value of the cell is now the thing after the semicolon. After the semicolon, there's nothing, so it doesn't display anything but the side effect. So total trick or technical detail, but that's why that's there, and it reveals the side effecting nature of the way that matplotlib is rendering here. Notice we zoomed way in. We sliced before we plotted, and that's because it's actually a pretty big raster here. Not big by our standards, we don't care, but by matplotlib standards, when it was written 20 years ago, it uses certain code paths that were fine 20 years ago, but we can easily handle a lot better today. And so instead of plotting this tiny little chunk, we can plot everything very easily and dynamically update as you zoom in. And so all we did is tell rasterize equals true. If you don't use rasterize equals true, what it's going to do is take that large raster, dump it all into the browser, and then the browser will downsample it as it's rendering it. So that if it's on a faraway server, that means all of the data has to go over the wire, fill up your web browser's memory, probably crash your web browser, and then you don't see what you want. So you turn rasterize equals true to make it server-side processing. Rasterize it at the server, please, before you give it to me, so that it will be just the number of pixels that are on my screen, so that I don't crash, I don't have to wait, and it'll look the same anyway, because that's how many pixels I got on my screen. So this is definitely a case if you have large remote data set and a fixed size screen, which you always have, use rasterize. And we chose log color norm. And with log, there's a trick. Log isn't defined at 0, so you have to clip the data. You do a color limit. Only show me things above 1, please. Or you'll get complaints about there being values below 1. That's just, log usually works, but it needs a special case at 0. EQHIS does not need that. Okay, so now let's go ahead and look at what this is. It looks like an image, but as you saw, you get a different image depending on how you zoom. That's an image. If you zoom in, wait, that's an image. There are lots of images. This is what is called a dynamic map. I apologize. It's a name. It was based on there being something called a hollow map, which predated HoloViz, predated hvPlot. And the idea of that is that it was all of your data. So hollow means whole. So HoloViz means handling the whole problem of visualization, not just plotting, but everything, and trying to get all of it onto the screen, onto your eyeballs. And in this case, a hollow map is a data structure. Like a hollow map of images would be a data structure where there's a key dimension on, there's some key dimension, like a stack of images, let's say. The hollow map is that dimension is a hollow map. So that you show an image, but you change the value of that dimension, you get a different image. A dynamic map is a hollow map, but every time you change that value, it recomputes the thing on the fly. So that's what's happening here. You can actually get at the individual image. So if I look at this object, it's a dynamic map of images. Now if I look at the last one that's been shown, it's that. Now that is no longer dynamic. You know, it doesn't do anything. It's just, that's one particular image. And the type of that is not a dynamic map. It's a type of image. And so this is a dynamic map of images. This is, or I can just print it. So that's what the colon is for. When it's deeply embedded in this, it's meant to say, oh, that's another object, and then you have that object's. But tab would have conveyed that as well. So anyway, so dynamic map is a bunch of images of which you see one at a time. You can always get at the most recent one if you wanted to, and that's how all of this works, which is that what's being displayed here is not just an image, it's a whole infinite collection of images where the key dimension is there is actually the size of this viewport, the location of that viewport in XY space, and the number of pixels. So that's what's indexing along this infinite set of possible dimensions. It's actually a dynamic map of images. It doesn't actually show what the values here are because they're computed so dynamically. But what they are this distance, not this distance, this starting value, ending value, starting value, ending value, number of pixels, number of pixels. That's what this hollow map or dynamic hollow map is indexing by. And every time you change one of those things, by changing those ranges, or by changing the ranges, or by changing the screen, I guess you could move this onto a different resolution, and that would change the number of pixels. Any changes in that gives you a new image. Sorry if I've lost anybody. It's okay if you're lost. The idea was to try to convey how this works so that you can understand when you start to see these representations. Okay, I got it. It looks like an image. It's more. It's a dynamic image from some space, etc. So, yes?
So does it like keep a certain number of those images and then start getting rid of them if you remove them?
Yes. I have totally forgotten those details because that was decided 10 some odd years ago. In this case, it wouldn't be helpful because it's very unlikely you would ever hit exactly the same thing again. So I'm pretty sure it's not keeping any. If you had some other way of interacting where it was just a dynamic map driven by a widget, well, that widget might have only 10 values. And even if it's dynamic, you could still cache that. I really don't even know if we support the caching. Maybe. But you certainly could. I mean, it's meant to be as if those things were already always there. Dynamically, they actually might be different when you hit the same thing again, because a dynamic map could be used for streaming data. It could be used for dynamic. Oh, when I go to this new thing, that means ask the stock market what the price is today. That's a dynamic map as well. So dynamic map, or literally anything, could change. It's making a function call instead of having the actual data. So because of that function call, you don't know that caching is safe, but it certainly could be. The dynamic map could be just an optimization, and caching would be fine in that case and useful. In this case, neither are fine. It'd be fine, but not useful. Other cases, useful, but not fine. Good question, though. Okay, so everything I've said here kind of isn't required for you to use the tool, but is super helpful when you're looking at error messages. What on a dynamic what? Okay. And often the best way to debug a dynamic map is to make it not be a dynamic map and then work with it, just like you did here. So get the last thing. At that point, all the dynamism has gone away, and you can do things like look at the data. That's an Xarray data set. I know how to deal with that. That's no dynamic anything. I'm using the Xarray backend. Like I said before, live in Xarray, stay in Xarray. Do your plotting with as minimal amount of extra work as you can, then get back to Xarray where you should be living, which is that's how you meld with your data. So you can very quickly get something and then drop into Xarray, and hopefully you know the Xarray API. I don't know it very well at all anymore. I've been in Pandas a lot more than Xarray in the past 5 years. But hopefully whatever you're using, that's the one you should really learn. That's not up to us. That's between you and Xarray. Figure it out. We're going to quickly get you access to it, and then you do whatever you want. And so you couldn't do this with a plot normally. Like, who knows what's in there? But that data, nothing's happened to that data. It's actually exactly the same data set that you passed in. There's nothing, it's not a copy of it or anything. It's just the data. And that's what's rendered. So, all right. Now what we've been building up to is to try to have multiple, this is a composing plots tutorial, and what we're trying to do is get you to be able to compose stuff. So we gave you a plot of magnitude over the weeks, a plot of the count over the weeks, and then we've got the severity over latitude and longitude. We've got that over a map, and we've got a raster of population. Now let's pull things together. Where were we? And overlay. So here we're going to overlay the population. This is left or right, remember. Population's in the background. The high magnitude points are in the foreground. We chose a dark color map, or dark and cool for the population. Therefore, you choose a warm and bright for the points if you want them to be visible. And so we chose, remember this, we chose a color map so that it doesn't start at black, or else very many of these would be invisible. So we chose the brighter end of the color range. We chose warm colors to distinguish from the background, and then we overlaid them. We only had to make all those decisions because we're trying to cram a bunch into one plot. As you saw, the defaults should already have been fine. Where your decision making comes in is once you already see how the individual thing is, you want to see how things work together. So you should never just start with this. You always start with the individual, and you make sure the things you're caring about are preserved when you try to cram everything into one plot. Whereas if you just always cram everything together, you'll probably mislead yourself because you will not even see the ones that show black in this plot, etc. So start with the defaults. They are good defaults, except for the rasterized ones where you should start with EQ hist and Dyn spread. All right. And here, yes? Yes, you can. In fact, there are 2 color maps here. Can you have 2 color bars? No. Why not? I don't know. I opened an issue about that last night. Somebody told me 5 years ago why there are not 2 color bars, and I said, well, make there be 2 color bars. I waited 5 years and nothing happened, so I chased somebody yesterday, and I was like, what? You know, this needs a color bar for that. Now, you can fake it, which is probably why I've never done it, which is you put an empty plot over here with the right color bar, and you just set it to the right, and it's going to work. And there should be 2 color bars on this plot automatically. And my principle is it should behave the way it should behave. And it's clear the way it should behave. It should have a color bar there. Why is there no color bar? That's a bug. There are workarounds, but you shouldn't have to enable the extra color bar. It should just be there because you have 2 things that are mapped onto color maps. So no, it is not supported. No, I do not remember why. Yes, it should be fixed. No, I do not know if it will be fixed anytime soon. We have no current customer that is giving us money to fix it. Never has anyone done that, so that's why it has not been fixed. If we're paid to do it, we do it. We also do lots of things we're not paid to do. If we have a workaround, we're less likely to do the right thing because we're busy and we do the thing. So here, yes, it totally should have that. All right, so this is one bit of a philosophy that hopefully you're coming to terms with, which is that when you have a bunch of tools, you could have a low-level tool that requires you to make many, many decisions in order to get the output you want. You have to turn right here. Oh, don't go there. You're going to waste all day. You're never going to get where you want. It does not go where you want. But you might spend a week doing that. If you know exactly what you're doing, it requires expertise from the entire space of decision making. And this would be a tool like Bokeh. Bokeh is a great tool. It is at a lower level than the tools we built on top of Bokeh. And you can make anything that you see in any of these plots, it could have been done with Bokeh because it is being done with Bokeh. Literally, the tools that we use are doing it with Bokeh. The code to do it with Bokeh would be many pages of processing events, catching it, rendering the image, making widget to explore dimension. That would be pages and pages of code. You have to know every line of code you write, you have to know how do you do that and how to get it to work. And if you want to combine things, you did that one way to handle the dynamic updating the image. You did another way to handle the having a group by with a widget. And then you combine the two. You start over and do them both together now because they're all interleaved in the same code, how you have to do it. What we've done in these tools is to try to make that not be your life. And one way to make that not be your life is to offer a high-level interface only. Then you make one decision, option A, B, or C. It's super easy. I do not want that. I want to be over here. Don't go that way. Don't choose this. I'll use that. Great. You're happy. But you're only sort of happy because you wanted it here. So you could get there. But if your choice is between a high-level tool and a low-level tool, those are both bad choices. Because you either have an easy life followed by misery, maybe you don't care. If so, great, you have an easy life. If you are very not picky, if the reviewer never told you to do something that you had to do, great, lucky you. You can use a high-level tool. If you only care about all the options of everything and want to script it all yourself and don't want some opinionated person making choices for you, great, use low-level tools. We live in this space on the right, though. We're trying to get you very quickly to something that's about right and give you a relief valve so that you learn, oh, I don't go this way, I don't go that way. I go here, I make this choice, and then I say this, and I change this setting, and I attach it to this object, and there, I get exactly what I want. This is our goal, and if we fall short on our goal, like in the color map one, it should be as easy as this, in fact. You should have already gotten straight to there. It should just always work to have the right color map. Now you have to figure out, how do I make an empty color map and put it next to my thing? Okay. That's one thing you can do, though. It's not that bad compared to, what is the theory of color maps? How do I map from color to whatever? Let me learn. That's what your life is on a low-level tool. And it's great if that were your job. We're assuming it's not your job. And we're also assuming that you have picky people, either it's yourself or people who are making demands of you, where the result matters. And your job is, your goal should be to get quickly to approximately right. And then when it matters, dive in and get it exactly right. And if we achieve what we're trying to achieve, we're going to be on this. Sometimes we end up here, like we don't realize, oh, that's a dead end. This is called my shortcuts, not dead end slide. This is a shortcut, but it's also a dead end, because to get here, you're dead end. You have to go all the way back to here, now learn everything and use this other way to get to the right answer. It should not be the case. We want a shortcut. Quickly get here, but not a dead end so you can get to where you want. This is philosophy, but it is a motivating philosophy why we bothered to write all these tools when you could have already downloaded Bokeh. You could have already downloaded Matplotlib 20 years ago, Bokeh 10 years ago. You could like, why did we do all of this work? We did all of this work because on a day-to-day basis, we hate this. We hate living like this, and it distracts us from science. Every day, we lost track of what we're trying to do. Oh, okay. Now, what was I even studying? Because you went off on some rabbit hole on building your plot. We want you to live here as much as possible, and when you have to live here, and to not live here unless that is something you actively choose. So if our tools fail to measure up to this, that's a bug report. Now, the answer to it might be, yeah, you're right. We don't have any funding for that. That is totally reasonable. But it is a reasonable request to make of it. I thought it should do what you said. It should get me close to what I wanted, and then I should have had a way. But I found out that I couldn't get there, or I found out that it really, instead of looking like this, I got there and then I had to go to finally get there. If that's your case, report it. Tell us. But that is not our goal. Our goal is to be most of your life like that, and when you care, to have it like that, and never be like that, and never be stuck. Okay, I think we're ready for another break. Oh, wait a minute. Instead of a break, a change is as good as a break, right? Let me start you on the example, and then the exercise, and then you can, as soon as I get it running, why don't you have a break, and then you can gradually come back into it. So the next thing in the list in the schedule, if you go back to the index, we've been going through these ones that are not indented. We're now on the first exercise, which is called, I can't even read that, plotting. So if you open that, this is the same as these notebooks you've been seeing before, but there are gaps. Your job is to fill in the gap, and if you're lazy, you can click on the hint, and if you're super lazy, you click on the solution, copy and paste, and then it's going to work. That's not very helpful. The goal is for you to struggle with it, realize, oh, it sounded good, but how do I actually do it? So I want you to hit some problems and then realize, oh, I can use the help, I can use tab completion, I can look at the error message and figure it out. So this is the case where you're going to not just do exactly what I said, but you're going to try to do what achieve the goal and follow the steps to achieve the goal and hit problems along the way. So if I restart, I'll just start you into it, and then the rest is up to you. And you'll have, I'll say you can go on a break, and then when you come back, you can either be working on it or keep being on a break. Doesn't matter. So I didn't mean to restart and run all. I meant to restart and clear it. Okay, so here we're just going to start by loading the data as before. We're going to get the raster data and the data frame. And then your job is to figure out, how do I get this object, which is the population density? So you're going to need to use hvPlot to get the data in cleaned DS right here. So you've got that. How do I use it? It's probably something to do with .hvPlot. So you fill in this ... here and try to do it without a hint. If you have no idea, don't worry, the hint's okay. Hint's not going to tell you everything. And then if you still are stuck, or if you've done it and it seems to work, compare it to the solution. Solution is not the only, probably it's the only way to do it in this case, but in some of the cases there are many solutions. That's just an example. So try it, see if you can get to the solution. If you can't, use the online help, call me over, or use the solution and work backwards. So ideally you'd get to the solution somehow. And the same for the rest of the exercise. So now you're on a break, which can be either a true break, playing with the exercise. We will come back in 15 minutes, which is 10:55 before 11. At that point, we'll just start again. So any work on the exercise, if your brain is full and you don't want to work on the exercise, don't worry, just take a break. Either way, we'll start back at 11, 5 minutes till 11. Thank you. Yeah, that's 15 minutes. And if you have any questions, feel free to wave me over or come up here. What's that?
I love that, like, I wish since I can steal it.
Go
with
for
the-
it.
I really find it, because we actually tell people the same thing of like, use the third party and then bounce back to us, but.
That's right. You use plot 9. Fine. And then you're going to hit a limit on plot 9.
The people go like, like, sequence breath and put, and not put them, wait, you
Not
see
even a
one.
counter.
Done.
One doesn't exist without multiple. You're confused.
Your plus and one plus max is that from hvPlot?
No, it predated GGFI.
Then,
There's a plus, there should also be a divide to put things on top of each other. We don't have that.
someone goes, from that one, they overload a little operator overload patch. hvPlot has a patch library that does that.
Right. Yeah, yeah. So it's patch, literally patch on to GGFI later.
No, I was, from my experience, that's what we get to is that, multiply semantics are how you add variables, and plus semantics are how you add, like, new topology spaces, so it ends up
Yeah,
not being the
it's
same
kind
way.
of the same. That's just because of how they work algebraically. Like, oh, okay, kind of makes sense. You could swap it and it'd be fine. It'd be very surprising in certain cases.
That's, yeah, that was the thing, you can't swap it, but
Well,
it's-
exactly. You can literally swap it, but if you do, bad things will happen.
Oh, yeah. It's one of those things, if you fully go into category and look at the code, the
Exactly.
base.
There's some deep algebra theory here that I'm not good at, but yes. This is a group? I don't know, maybe. How should groups behave? Oh, it's a ring. Oh, it's a ring. Okay. I don't know.
Working with someone in the submodules, and I was like, what's the definition of submodules?
It's paltry, it's barely there. This is not a full theory. It'd be great to have a full theory and great to have multiple operators. Because layout is miserable. It just adds to a long string and you can reshape it to a column or a row, but really it should be laying out in space and operators to help deal with space, but we don't have that.
We have, I like our subplot mosaic, we try to not point it.
Subplot mosaic, oh my god, it's the best thing ever.
I mean, the fun part is I'm pretty sure, it was originally because somebody wanted patchwork, and we're like, we
I
can't
remember
do
that.
patchwork.
Yeah, it was because I never figured out the subplots. At some point, whenever I hit a subplot at the time, okay, student, enjoy. But with subplot mosaic, it's like, oh yeah, I can do it. I can do it myself.
I know, it's great. To this subfigure mosaic, because the subfigures are also mesomers.
Yeah, yeah.
It's like, yeah, I have how many layers now? I'm surprised that the VAS isn't working, because like, I've been putting my VAS in my filter.
No, let's go ahead and try it. I don't think anything bad's going to happen. When that was written, it was several laptop generations ago. So let's go ahead and not slice it. Let's see, 1, 2, 3, 4, 5, 6. Okay, that's enough for most people to decide it doesn't work. Even if it will work, most people say, oh shoot. Yeah. So, but it's not horrible. It's slow, but not horrible. So the fact that it came up is fine.
Oh, so this is running through Xarray, right?
Yes.
Yeah. I'm wondering if Xarray has, Pandas matplotlib needs a rewrite. So, and I wonder
Mhm.
with Xarray how many if they also withstand some optimization.
Yeah, probably. So, 1.63. Oh, that's not bad. The second time around it's faster. And, oh, well, it actually hasn't appeared, though. You quickly get that number, but it's, I guess, that.
I wonder if time is.
Yeah, so anyway, it's under 10 seconds. People will wait 10 seconds, and at that point they get antsy.
Oh, no, I know. And we do have users who are doing like, they're trying to.
Whereas that is instantaneous. That's why we do it. We just selected, and so you say that that was trivial. So this behaved well. Whereas that is, so these tools do the same for the entire world as the other ones does for Indonesia.
My first GSOC, the do your selection and stuff server side and then pop it up into the web.
Yeah.
These things exist.
Right. And it's this, the weird thing is that nothing's changed about data visualization. Like, these are all things that could have been known 20, 30, 50 years ago.
Half of them were, like tools exist. I forgot what the name of it was. Like, the guy who wrote Basemap also wrote like a server side, I think processed in IDLE or IDLE and CI, did server side processing to pop up into the web. Oh, Fed.
I've heard that.
Yeah, right, so like all of these tools are necessitating different iterations.
Yeah. And I just feel sad and bad. Things like units. Xarray keeps track of units, but why doesn't Pandas? Why can't you have a unit in a column and just, because if it were there, our tools could use it automatically. We've known about scientific units. When you do math on the units, you should be able to follow that. Like, why was this not 50 years ago?
Pandas does that now, or it will let you do it because you can do the complex details. So you can put the unit.
You can put the unit, but then it won't be respected as you do transformations, which is the whole point of, like, and that seems like just basics of science. That's what happened to the Mars lander. The people didn't keep track of units. Why is that not just done for us 30 years ago?
And I'm surprised because I did think that Pandas had a unit of
It can do it. No one does it, and therefore, like, everyone just acts like it's okay. It's not okay to just casually lose track of your units and then put them back later for your figures. Like, do you realize how often that can go wrong?
I work with the GHCN data set. Yes.
Yes, and it's like, so these are not, this doesn't require new technology, it just requires people being disciplined and caring and doing it right, preferably 30 years ago. But if not 30 years ago, at least today. So, I don't know if you know Tom Nicholas. He added good unit support to Xarray, and that does propagate when you aggregate and select and so on, and complain when you try to aggregate across incommensurate dimensions. So, but that's in my lifetime. But units have not changed since anyone here has been born.
No, I mean, like, high-end, and I forgot what, there was another units library.
There's
besides
Pint, well, there's AstroPy units, and that's a problem that I hate, which is that why is that in AstroPy? Units in Astro do not differ from units in Agro. It is nothing.
Well, I was looking at the spread, the mind map bug chart thing of the parameters and last thing. YT is part of the Matplotlib ecosystem.
YT?
Yeah.
Yeah, it's built on Matplotlib, yeah.
It's also like, but it's also just full volumetric data. It doesn't, like, I think for like 2 minutes they were because they were trying to get CCI money. They were like, we can do other things.
Right, right. Yeah, they acted like it was domain general. It really isn't. But
I think it's everything I've heard about YT is it's a very closed.
it is. We added support for it a long time ago in Panel. I'm pretty sure nobody's ever used it, and they're just their own community, and that is fine.
It's actually just like I talked to at some point about how Panel supports Matplotlib in its dashboard. Because you guys, you have interactive Matplotlib,
Oh, that's a limitation. We have not had much success using the widget backend for rather than the inline backend. For inline, it's fine. You have to be careful to make sure you grab the actual rendering as opposed to the side. You have to use the non-side effecty interface, the object-oriented, and if you do that, then it behaves well. And you drag a widget, and it updates the plot. We'll show examples of that with Matplotlib, and it works great for the non-interactive case. But we have never, no one's ever said, what if we can make Matplotlib as interactive as you can? People just think, well, let's just jump all the way to true JavaScript, full integration with the browser. But Matplotlib could get very close, but we haven't, nobody's invested in that. Nobody on our team is invested, and none of our customers have wanted that. But we could totally do it, and I always feel bad, because we don't want to act like Matplotlib isn't interactive. It is. It just has super ugly widgets, and it's janky. But it can be. If you need Matplotlib, it can be interactive.
Elliot, I think, is working on the Augie backend.
Great.
Backend.
Yeah.
That's
If you get a proper JavaScript integration, we're going to love that, because there's tons of Matplotlib plot types that nobody has ever said, never found worthwhile to re-implement in Plotly or Bokeh, because it's just like everything is in Matplotlib. So if we just have access to that, but not lose our ability to select a point and interact with it, that'd be great.
yeah, oh, yes, I will find possibly Kyle and Elliot.
Great.
That's also part of, I think Kyle might even have some demos.
Very good. You go. So don't mind me, I'm just going to go through the, and put up the solution for anybody who didn't go through it, just to see. You can watch that or not as you like. We're not officially back yet. All right, we're back. Hopefully you were able to guess your way into things, or at least didn't feel too bad about cheating and using the solution. At the end, I don't remember why it says to do the box select tools, but I had to explicitly enable the box select tool. This one's the box select, and it does work if you enable it, but it isn't there by default, so I don't know why it says that. Somebody wrote it maybe at a time where it was there by default, no idea. The box select does seem to be selecting the least some of the data there. Selects the, on the red one. So box select works, but you have to add it to this list of tools. And bokeh options, tools really means extra tools because all the rest are there by default. So it means tools other than the standard ones. And if you want to redefine the standard ones, if you want to get rid of one, then you have to use, I think, default tools. There's another term for it. But you can control what tools go in that toolbar. If you don't want your users to be able to pan or select or zoom, you can control all of that. But I totally don't remember why we are telling you to do that, but that's how you do it. All right, so we're back. We're on tutorial 4. Time check. We have let's check the schedule. The official ending is at, what is 240 minutes after 8? Is it noon, right? So we officially go till noon, so we have 1 hour left. I try not to linger too long over the later ones because I know people's brains get full. Mine gets full, my voice gives out. We try to make the absolute essentials. Well, actually, we tried to set it up so you get something out of every single one. And if you stop there and you got to run off to somewhere, you've got something you can work with. So in the first one, what you had to work with is, I can invoke something with hvPlot and I get cool interactive stuff. Then, oh, what I got back was an object, and now I can combine them together and I can do whole layouts. That's cool. Or overlays. That's cool. And you run off with your life and you got that. The next one, we're going to talk about how you make these plots work together. And then we're going to talk about adding, it says interactive. We're going to rename it after, I didn't want to rename it yesterday because it might break things. But tomorrow I need to rename this whole thing to reactive expressions. We're going to talk about how you just turn anything into an app. Any sort of workflow that you have, like if you select magnitude over 7, why 7? How about we make a widget for 7? And it's as simple as that. It's literally as simple. Wherever you see 7, you pop a widget in there. So that's what that you'll get to after this. So first, this is the last topic that just relies on hvPlot interface, and then we'll move to panels interface. It lets you do arbitrary any sort of expression you want and make it into an app. And what I would hope you get out of that is that you walk away thinking, I could actually use this in my research, in my daily life. I can just put a widget there. Like instead of making a loop and trying 10 values, I can make a widget and try infinite number of values. I can just try everything. And trying to make it be totally as trivial and as simple as that. It's not, should I start a JavaScript-based web project and hire some front-end designers? Sure, maybe you should, later. You should immediately be able to have interactivity, though, just in your daily work. It should be a matter of seconds. It shouldn't be months or millions of dollars. And so that's what you get with number 5. That's just lightweight interactivity. Just things work dynamically. And then we'll get to putting together into a more formal dashboard where you're arranging things and you have some concern over this is an object that I've created, or an app I've created, or I might be sharing. So you're adding more structure to it. And then these later 3 we will have very little time for, but this is how you get deep interactivity. What if, like in my ship traffic example, if you clicked on it, you looked up things about that ship. Well, how do you define that behavior? It's more complicated. It's not as trivial. It doesn't use the standard .h.plot API because that wasn't a feature of the .plot API. So you have to learn new stuff. And so we put the parts where you have to learn more compared to what you get. Those are at the end here. And we'll probably not have much time to spend on those. And in the end, we'll pull it all together into how to build complicated applications. But for now, this is the last hvPlot only topic. And what it is going to show you is how you can have, for very little effort, cool ways that plots are linked that really help you when you're trying to understand data and explore it, but are very hard to explain. So the simplicity, it's a whole notebook, not because it's got a lot in it, but because what's in it is hard to explain. So let's get those most severe earthquakes. And then we're going to plot a couple of histograms, and I'll come back to what we're doing here in a second. But let's get a histogram of magnitude and a histogram of depth. There's magnitude and depth. These are next to each other. By default, when you put things next to each other that have the same axis, notice the y-axis is shared. They're both count, so they are linked. The x-axis is not linked because one's showing depth and the other one's showing magnitude. Now, I can't drag left or right without jiggling it, but if I were dragging perfectly, the one on the right wouldn't change as I do this. So that means this axis and that axis are the same axis. It's called a shared axis. So that's you get that out of the box. If HoloView sees that two things are the same dimension, usually that means they're the same name. If you've declared units, they should also have the same units. There's some other things about it that determines whether it's a unique dimension. If you find things linked when they shouldn't be, usually it means you should tell us more about your data. We connected it up because as far as this one's y and this one's also y. Okay, well, this one's height and this one's weight. Those should not be the same. Don't link those. But HoloView doesn't know. It trusts you. It says that they're both labeled y. That's the same axis, and they should be linked. And they will share the same. When you zoom in on one, it'll zoom in the other because it's assuming that there's a reason you put them in the same pair of plots here. You're probably trying to compare them if you've got the same thing on y. And so it's making assumptions about that. You can override those assumptions totally. But by default, if you've plotted them together in the same structure and they have the same name, it's linking them up because that's what you should be wanting. If you didn't want that, you should have said they're different. Anyway, that's just this basic behavior of plus, or the layout operator. But we've done something more here, which is that we've linked not just the axes, we've linked selections between these two plots. That's easier shown than explained. So if I make a selection, if I only select the highest magnitude earthquakes, the selection was reflected in this plot too. This is called linked brushing, if you've never encountered that. What it means is that I have dynamically filtered the data to only the high magnitude ones, not just in this plot though, but in every plot. Like if they all share the same index, even if they don't share similar dimensions, you've filtered it so the background shows the whole data set, the foreground shows only the ones with this particular magnitude range. And that's what you see over here in this plot. Not the histogram of everything by depth, the histogram of the magnitudes from 8 to 8 and 8.4, those values are what's being shown here. And so if you zoom in, you'll be able to see that. You can drag axes around. Okay, so if I can let go. Since I selected these magnitudes, you'll see that that's been highlighted here. Those are the selected ones. These are the reflected ones. They're the ones that have been filtered from all the depths that are available, all the counts, only the counts of the ones that are in that magnitude range. That make sense? Now I can select again. Well, what if I see this is some shallow depth earthquakes and some deep earthquakes. What if I only select the deep ones? I'll use the select tool again. So now it's jointly filtering to this depth range and this magnitude range and showing the intersection between those, which is now very small. There are only a few that are in this magnitude range and this selected depth range. There are 2, it looks like. And so what this does is it's hard to explain, but this allows you to see something interesting on any plot and to see how that relates. Like, do the high magnitude ones, do they generally occur at a certain depth? Oh, it looks like they did. They were either very shallow or very deep. Oh, okay, I'm only caring about the deep ones. Do the deep ones, are they in this magnitude range, are they higher end of magnitude? Oh, it looks like they are. And this is a way for you to interactively, without writing any code, explore deep relationships between any part of any data set on any plot, with every plot, everything else that you're seeing in the same plot. in the same layout. So it is super hard to convey just how useful this is. But if you can show, if you got a multidimensional data set, say it's like 10 dimensions, and you figure out, I'm gonna plot this versus this, now this versus that, and this versus that, and this versus that. You see them all. And now you see something really cool. Oh, it's linear in this one. I'm gonna select the high ones on here. Are they also the high ones in that dimension? No. Oh, they're the low ones in that, or they're uniformly distributed over there, and so on. So this support is, normally you'd have to write a whole, it turns out that link selections is implementing what people have written entire dashboards for, and they think, my job is to write a dashboard for this data set, where if I select this and I get this behavior, it's because I want to understand the relationship here. It turns out that can be solved for all time ever, and it's just this. And a good example, I don't know if it's up right now, but Glacier's HoloViz, or Glacier's panel. I got to say more. HoloViz. There's an example on there that this was not using this support, or maybe it is now, but originally is setting that up for exactly what I just said. So you can select by select a geographic region. Well, are those tending to be glaciers that have lots of precipitation? Select the ones that have lots of precipitation. Are they geographically located? And so on. The ones that are high temperature, do they tend to have more rain? All those relationships. This was all hard-coded in this app originally a long time ago, before we had the support. But that was piece by piece for those particular relationships is all set up so that you trigger things on each of the other plots. It's just been done for all time for you forever. And if you don't understand it, it totally makes sense because I don't know how to explain it very well. But try it with your own data and you'll realize. And you can even do cool things like, how do you even access it? You can change how these plots intersect. Okay, right now it's choosing when you make a selection, it's the joint, it's the intersection between all your selections, but you can actually do disjoint sections. I want this part of here and this part of there. You can do multiple selections. How do multiple selections combine? It's this, this, and this, but not that. You can do all that, but I totally don't remember how you invoke that in the interface. There is a way that you select, oh, it's a plus operator between the different selections. It's a minus and so on. So it's in there somewhere. You look up the link selections page. I hope it'll tell you. Okay. So here is an example of where it's particularly useful because if you just see the entire world's data, that's great. But if you're a scientist, you're probably looking at you have a particular specialty. I only want to care about New Zealand earthquakes. Okay, now let's see how the New Zealand earthquakes compare to the world. Done. It's so easy to express that. You just point to New Zealand. That's it. You don't have to do anything else. You don't have to write a single line of code and then just say, oh, well, actually it's New Zealand, but some of my funding comes from, I think if you hit reset, it'll reset everything. So my funding comes from South America, so I'm going to do that one too, and I'm going to compare it. No coding needed, just works. And once you've selected it, by the way, it's a Python object, so sure it displays as this thing, but like with everything else, what you've selected can be accessed, and it'll be whatever you last selected. Just like with the .last for a holomap, you can get the filter that it's using. I think that you can do this. Yeah. So this is hard to read, but if I just look at if we ask this link selections for its current filter, it's super hard to read, but what it is selecting, you look at this expression, the selection expression is saying that the easting is in this range. That was the longitude from here to here. I drew a box on latitude and longitude. It's called easting and northing in this projection, but whatever. So it's this easting range, this northing range, and I mentioned that there's a selection mode that was, that's about the plus and minus of, and this particular one is an overwrite. It's this whole nested hierarchical way of expressing a filter. You can get at that filter, and then once you've gotten it, you can then apply it to your data and say, when you saw something in the plot, you can now filter your data by that. Give me only the rows that have been interactively selected across these two. Like if I made it'll give me the data that's a particular depth range and a particular geographic range, and then I can actually work with it. So it essentially gives you a UI for working with your data. Once you've interactively selected it, great. Now you can do numerical stuff on it. And like I keep saying, the plot should get out of your way and get you right back into the Pandas or the Xarray API whenever appropriate. Okay, there's an exercise. You can play with it yourself to see if it's working the way you think. That's all it says. Try to select a tiny number of earthquakes and then get this to update. I don't know why right now it's not selecting that. I found that refreshing the page makes it do it. So let's just try it. Yeah, I don't know what. Somehow something's gotten confused. Restart and run all is your friend in any of this stuff. Okay, so here's a big plot. Let's go ahead and select just a tiny number of earthquakes. And then look at the result. That was only 3. Okay, so you can see that whatever I was selected, now you're back in Python, you're back in Pandas, and everything else is Pandas. And you do whatever you want at that point. So you essentially got a UI for filtering and selecting your data for free by using this object. Yes?
The linked filters, the current behavior, is it like use alpha to make part of the graph more transparent?
That's right.
Are you able to switch that to where it just eliminates all the other data and only shows you what you selected?
Yes, there's a selection alpha and a non-selection alpha parameter. And you change the non-selection alpha parameter to 0, and then you won't see the background data at all. So those are all set up to be by default, but it's totally trivial to change that. Often it's confusing if you set it to 0 if you're going to reuse this, because if it's 0, I wouldn't know there was data anywhere else. So you want it to be in the background. For most usage, you want it to be in the background, but you want it to be somewhat visible, so you can choose, oh, now I don't want that. I see there's data over here, I want that. Great. But if it were 0, you just have to you'd always be hitting this reset button, which you can do. It's fine. But if you only need to do one step, that's what you would do if you want to support it. This design, that's why the defaults are the way they are. Okay, that's the end of hvPlot. I think in the interest of time, I won't spend time on the linking plots example, but I will just show you. This is an exercise you can do yourself. I'm sure that if I show it to you here, you'll remember everything, so it would be useless to do it again. I'm sure of the opposite. That you can see it all here, but still it'll be worth going through your own self. So I'll just show you the results so you can see. This gives you a plot of latitude over time. This will give you a plot of longitude over time. And lays it out next to the other. Okay, so hopefully you'll be able to guess the syntax for doing that. But if not, you can cheat and use the solution. And it shows you how to use link selection. I didn't really talk about how you do that, but you'll see in the code. It's not. It could just be as simple as link selections, parentheses, whatever you're going to do, but often you want a handle on it so you can do the filtering and things like that. That's why, so just pointing out that that's why this is a little bit complicated. First you get this link object, and then you apply it. You could totally just do link selections in this. That would work, totally work. But if you ever want to do filtering, you've lost it. You can't get back to that link object anymore. So first you grab the linked selections object, and then you use it. Nothing mysterious going on there. Just if you want to ever work with something in Python, you got to grab it before it disappears. That's why we're doing that. Okay, now that's setting it up to link, and then showing you filtering. Okay, I highly recommend using link selections with your own data, and I highly recommend doing it via this exercise so you get hands-on experience with the data that you know works before you do it with your own data and you don't realize why it's not working. This will hopefully give you the experience to make sure that does work. Okay. So now, reset your brains. We're done with the hvPlot. Well, we're almost done if I answer these questions. And then we'll move on to things that don't even require hvPlot, are valuable and useful with or without hvPlot. The initial examples will use Pandas data frames alone. It'll use matplotlib. They do not require hvPlot, but they pair very nicely with it. And we'll first introduce it, and then we'll bring it back around to hvPlot. So, question in the far left.
So my question is there a way that you have a link plot that has the axes dynamically update relative to the data that you selected?
Yes, if you notice that when you selected, this is related to showing the background as alpha and dim back there. As far as I know, there's not a way to have it, right now it automatically is scaling the axes to the whole data, but now once you've selected this tiny little bit, you can't see it, and it's really awkward to zoom in there, and when you make a new selection, it loses the fact that you zoom in. It's super irritating. Please file a bug report and be a concerned citizen. It should be possible to pass a flag to it, say, don't respect the whole data, I only want to see the zoomed in data reliably, and even if you don't, also just respect my zoom, so when I select a new value, I don't want it, so one of those options should be available. For all I know, one of them is available. I'm pretty sure both are not available. Both are reasonable and useful. Please ask. Okay. Anyone else in the same area? There was someone? Okay, so no more breaks at this point. We're just going to power through. But this would be a natural state for a break, so just try to calm your brain. You got as far as you're going to get with hvPlot. If you want to go further, there are later tutorials about dropping down a level to hollow views. You need to do that. There are a lot of things that have not been bubbled up to the hvPlot interface, and that's for a good reason. The .plot API, we try to pack as much power in there without you having to learn anything new. Like a few extra keywords, that's it, like rasterize. But otherwise, it's all stuff that worked with .plot and matplotlib defaults. Should keep working, and now you have all this more power. That's hvPlot, but there's a whole lot more you can do with dynamically, like you click on something, cool stuff happens. We do a lot of work on there. That's at the hollow views level. It'll come back to you in a later tutorial. We won't really have time to spend on that because I wanted you to get this stuff, which is more general and more useful for daily research, less about making the world's greatest app and more about quickly getting interactivity that just does what you're trying to do. So the theme here is instead of everything else before was about hvPlot respecting the .plot API and the API Pandas, this part is about respecting Python. Just anything in Python. It allows you to capture it and make it reactive. So let's give you an example. Before we do anything, let's go ahead and get a hold of a widget. Panel is our widget library. It builds on Bokeh and it builds on IPyWidgets. We're going to focus on the Bokeh part, but Panel has lots of widgets. Just go to the Panel website. You'll see tons of widgets to choose from. For instance, it's got a slider with a value that is of type float. You can immediately look at it. It works well in Jupyter. Does nothing by itself. But here's the basics of using it from Python. If you ask for the value, it'll return the current value. If you set the value, it'll update it. So this is how you use it from Python. Very straightforward, but it's kind of manual. You have to update the Jupyter cell to work with it, but you could totally have this at the top of your notebook and then rerun the later cells. It'll work, it's fine. But it's not what we call reactive. And there's an exercise, basically it's do what I just did there. Show that, that you can change those values and it'll update. In fact, it should complain about things that aren't valid, like that. Oh, it should, why does that not happen? I think that should have been an error. Andrew, why is that not an error? got these. Anyway, that's total aside. So, okay, now here's how to make this expression reactive. If you're familiar with JavaScript React library, it's a similar meaning of the word reactive in their case. Independent implementation, this is not built on React. Whoa. I'm going to reload because I just did something that I don't know what it did to my notebook. I leaned too long on the return button. I hope I didn't delete everything. So let me restart and clear outputs. All right. It copied that, I think. Okay, here's where we were. So let's read in some data. And I'm going to tell you a story. And the story so far does not involve panel, does not involve hollow views. It just involves Python. So stick with me. This is the Python portion of the story, and the, in this case, Pandas portion of the story. With Pandas, you can read a data frame, you can select some columns from it, and you can filter it by magnitude and take the head of that. And you can filter magnitudes over 5. This is all good. This is, if you don't know how to do this, that means you should spend more time with Pandas or with Xarray or whatever your data library it is. This is just the basic way these libraries work. That's great, and it gives you one particular thing. But what if you wanted that to be a widget? What if you wanted to change, so just take the same expression and replace that, but with a widget. The way reactive expressions work is just do that. Just literally put in a widget there. Okay, we're going to turn this data frame into a reactive expression. You do that by calling reactive expression Rx on it, and you get a reactive data frame. And now you do exactly the same thing as before. Well, in fact, if you don't have a widget, it should just look exactly the same. It's a reactive data frame, but you have nothing for it to react to. But what if you add something for it to react to? A slider. Now you add a slider, and now it should react. For different values of it, it'll filter. I don't know where, there's magnitude there. Here it's filtering anything over 1. Now it should be filtering things over higher. So you'll see that 7.4, oh, only 7.6 are left, etc. So there's essentially no new syntax. What you've done is wrap your object here, and then now you have the ability to put a widget wherever you had ability to have a value. Now that is deep, deep magic, right? Like Pandas filtering does not accept widgets. So how does that work? Well, the way it works is that a reactive data frame is exactly the same as a regular data frame, except it's lazy. It's the same laziness that hollow views plots have, or hvPlot has. It's not a plot until you look at it. It's a Schrodinger's cat kind of thing. Until you look at it, and then it's suddenly a plot. When you look at it, it's suddenly a data frame. Until that point, it's a promise of a future data frame. It's a wrapper around a data frame that builds up operations on it, like this one, selecting the mag out. That's an operation, selecting the magnitude. So that starts with your reactive data frame object here, RDF, and it records the fact that you're selecting the mag column from it. So it's now a promise of a future selecting a mag column on that data frame. And if you look at it, it'll select the mag column and it'll be done. That's all that ever happened. But more can happen because it's indirect. It's holding that in memory in a little expression, and then it adds this bit here. Now it's a reactive expression with an input. Aha! This is a reactive expression that is not just going to display once. It's going to update whenever. It's going to watch the value of mag slider. There's an underlying property called operation called watching. It's going to watch the mag slider, and whenever that changes, the value of this expression is going to change. And then that expression goes into this higher expression here, and then that expression goes into this. And so this whole chain of things is replayed every time I drag this and let go. So it's a little confusing. It's like, oh, nothing's happening. That's because earlier we said throttled equals true. you can turn that false and it'll update for every value on there. And often that's not going to work very well. Because if you do something complicated, it's going to try to update it for every value as you drag it. It'll work great in some cases, but it's safer to turn it off by default. And so that is literally all that's happened here. Is this, you wrote an expression in Python. This is normal Python. We're not hacking Python. We're just using the fact that Python allows you to defer operations, such as there's an underlying definition of what it means to do array indexing on an object. We re-implement that. We say, don't do array indexing. Make a note that you're going to do array indexing and do it later. So basically defer and delay everything, everything. And there's a list of something like 15 things that don't work with this. Turns out len always must return a number. It can't return a promise of a future number. Len, oh, come on, len. Okay, len's a special case. So you need a special reactive len. And there's like 10 other special cases out of all of Python. Everything, almost everything in Python has an underlying operator syntax, underlying things that can be implemented. So it doesn't do the thing you asked for. It does the make a note of it and do it later when you dynamically ask, such as when you display it in Jupyter or when a widget changes or some other operation happens. So you can check it out. This is all defined in the param library. But the vast majority of things you try are just going to work. You start with a number or a string or a list or something. You change it to a widget whose value is a number, a string, or a list, and it'll just work. And when you hit something that doesn't work, it's very irritating because it should have worked. It's a limitation in Python. They thought of many things. They didn't think somebody would do something crazy like this. But it nearly already works with just standard stock Python. We didn't change anything about Python to make Python into a fully reactive language. Like fully reactive, because I can, if I change mag slider, I can update mag slider over here. And then this thing down here will have updated. And look, now they're all, this entirely different cell is responding because it's sitting there watching. All it does all the time is watch. It's waiting and waiting for something to happen on this, the things it's watching. It's watching one slider. It's going to watch lots of things. If I put a slider for this, I could put a drop down to choose which column I wanted. Whatever. I can add interactivity wherever I want, and it just works. It's crazy. The output doesn't have to be a Pandas object. It can be, in this case, it's a tuple. It can be literally anything in Python. It can be matplotlibplot. This is panel working with non-interactive matplotlibplot. It's just instant interactivity. There's no special syntax. It's exactly the same thing as any other way you would make this plot, except that the mag is now a slider instead of a number. If you know how to do it without interactivity, you know how to do it with interactivity. Just replace the value with a widget. That's it. So you look at the panel website, you choose your widget, you look at your data type. Anywhere that data type would make sense, you can plug it into your expression and you're done. And so we highly recommend that this is just how you, if you want to say, oh, how does it vary with magnitude? Just do it. Just make a widget for that. The alternative would be to keep editing this value. How does it work with 4? Okay, now how does it work with 1, etc. You can totally do that. Or you can just make it be fully interactive and it's exactly the same cost. And with one widget, it doesn't much matter. With lots of widgets, it quickly becomes very hard to do anything without using this interactive approach. So obviously, I wouldn't have told you all the stuff about hvPlot and have this not work well with hvPlot. So it does not require hvPlot. It literally works with anything in Python. If it can be displayed in Jupyter, it can be returned, and it will be displayed by Jupyter. We are not in charge of how it is displayed. Jupyter is. We register things for hvPlot to make hvPlot display nicely. Yes, we do that. But anyone else has done the work to make their thing display nicely in Jupyter, it will also work. So you can use this reactive interface with any plotting tool you like, with any non-plotting tool, with a SVG renderer or HTML equation formatter or whatever it is. You can control the parameters of it and just do it as simply as this. You can use a date widget. The value of the date range widget will be a tuple, of course, of timestamps. The return from it can be a string. That string should be updated. I don't know if it's, did I not connect that here? Oh, I have, sorry, this is not a dynamic return here. I'd have to make that be a, this is a static string, but I could make that with pn.rx. It should just automatically update. I've actually never tried that. Okay, now will it update here? Oh, it should. Anyway, I'm probably confused. I don't have time to linger on that. I'm surprised that didn't. Anyway, to get to the point, now we'll add a couple of widgets, the date range and the slider. That should update the data frame representation. If I drag this one, it should update. If I drag this one, it'll appear not to update, and that's because it's starting here, and there are lots of things. This is only changing the end of it, which we won't see, so that doesn't mean it's broken, and probably the thing above wasn't broken either. I just don't have time to linger on it. All right, and so for an exercise, you would don't actually do this, but you can choose different columns, filter on them, just try it yourself with your own stuff here. And one more thing to convey, which because the rest of the time we'll want to have you work on your own stuff and trying things out and getting help from us if you need it. The last thing to convey is that we use special work if you have a function. Like if you've already, notice that we didn't require you even to write a function here. It was just literally any expression you can do in Python. But if you have gone to the work to make a function, what we've done is allow you to bind this very explicitly, this argument to a widget. And so if you've got a widget, you've got an event type, bind that argument to a widget. So it's something called pn.bind. We say, given this input function, I want this widget to be bound to this input. And then the result of that is going to be a reactive object just like you had before. So here, we wrote this function which takes event type. The event type might be query blast, let's say. This is showing you all query blasts with a magnitude of 3.7. Now, there are none, because that would be very big query blast. But if you lower it down to a lower magnitude, you'll see there are a couple. And so this is doing filtering based on this function. And so if you can write it as a function, it's super easy to just bind the arguments of that function, to bind widgets to them, and then you get a reactive expression that works the same as everything you've seen before. So reactive expressions do not require you to write any functions, but writing functions is good. And those functions, note, they don't have anything to do with panel. There's no code in there that's specific to widgets or anything like that. It's only at the binding step. Is there anything about the dashboarding library or the widget library? And so that way you can write all your code like that, lots of code, complicated domain-specific stuff, great. None of it is tied to widgets in any way, and you can bind that to widgets just for the purposes of being displayed. So it allows you to separate your scientific concerns from your GUI concerns and just bring it in at the very last minute, map widgets onto what these functions need, and then you get the UI, but your code in no way depends on panel, which it shouldn't, unless it's GUI code. And if you're writing a GUI, yes, depend on panel. If you're writing science, don't depend on panel. So, and then you can do the same thing with, use this stuff with HoloViews. This is hvPlot, which eventually is HoloViews objects. This will all work the same as it would with non-HoloViews objects. And then lastly, just putting it all together, this is how you build up an app like we were promised at the beginning. And I'll skip this section at the end. It's a little confusing, but what if you can't handle a promise of a value someday? What if you actually just need to get it into a value? And read this section, and I'll talk about how to do that, such as if you wanted to use link selections. Okay, well, I will stop there, and pretty much the rest is up to you. You move on to the building pipelines exercise and either follow what it says or go rogue. You can skip all the way to the advanced dashboarding section if you want, which is freeform, i.e., just do whatever you want. Try it out with some data set that you have, some data structure that you like. If you like Xarray, use that. Pandas, whatever. If you want Network X, use that. Use some data that you care about and you're interested in, and explore that. And Andrew and I will be around to, this is your chance to have somebody who knows what they're doing, has done a lot, has encountered all these errors that you're going to get before, and explain it. And that's, I should have a caveat for everyone. High-level tools are great. Layered tools are great. Layered tools where the error is encountered 5 layers below where you're working, not great. You're going to get error messages sometimes. Usually we do our very best to catch them at the highest level possible and explain to you in words that mean something to you. Oh, I can't pass that in because that's the wrong type of quantity for this operation. But sometimes we won't have anticipated that you would ever do that. We had no idea. And so what you're going to encounter is a layer error message lower and lower down. And it's like, NumPy is complaining that you can't compare a date time and an integer. That's where these tools, I mean, there's really no way around it. I mean, there really are these different layers. There are these different levels. Trying to implement hvPlot from scratch without building on NumPy and Bokeh and so on would be insane. But it does mean that when you encounter errors, you're going to have some trouble navigating the hierarchy. And you encounter more errors the more beginner you are, because you do the things you don't realize are dumb. Nobody should realize it. You don't realize that shouldn't be done, so you try it, and nobody else realized that somebody would try that, and so on. And so it's very normal and natural. You will encounter errors. If you are lucky, there will be errors that other people have encountered, and that we put in good error messages, and your hand will be held. If not, call Andrew over, call me over, and we'll try to help you through that. But with that, enjoy, and this is your time to either take your brain offline or try things while we're here to help you. Thank you.
the assumption that the person has Jupyter up and running physical.
No, so I just got a good question, and I should have made this more explicit. The answer, I use Jupyter. I love Jupyter. Jupyter is the greatest thing ever. But if I want to share something with someone who doesn't know Python and is not a programmer, they just want to see the data and interact with it, that's when you use something like this. This is a deployed server. This is using the panel serve command. So you save your notebook. If you want to start with a notebook, you save your notebook. If you don't, just put your code in a Python file. And then you do panel serve file.ipynb or panel serve file.py. It doesn't care. If it gets an ipynb, it strips out everything about the notebook except for the actual code, runs that, starts a web server, and this is all nothing to do with Jupyter. You don't have to have Jupyter installed. It is 0 Jupyters involved in the production of this, this web application. And so the final app, which is what you get if you make it all the way to the end of the tutorial, the monster at the end of the book, tutorial 9, is this app. And then I did panel serve with some port number, 5006, and this is what you got. And so that could be run on some EC2 instance, and it'll give you, and then as long as you control access to that, you can share the address of that to somebody else. You can add authentication in front of that. You can deploy it in other ways. Anything that can handle a web server will work with this. And so, yeah, I use Jupyter for teaching about it. In no way is it required at any point in the process. If you want to find out about deployment, just visit Panel's website under deployment. It'll talk all about deployment. There's Heroku, I don't know, there are 50 options. They're all bad. They're all pain. Deployment is a pain. There's a lot of companies that exist to solve that pain. We have a product from my company to solve it. It has a big red, green deploy button. It is so great, but not many people have that product. It supports lots of stuff. So many good questions. Someone's asking about WebAssembly. If you go to the Panel website, you'll see all sorts of things that do not require deployment. Panel, I don't know even where. Maybe it's under getting started. Yeah, this is all WASM-based, pyodide, running in the browser. So this is, most of our websites are just static HTML. They don't ever call out to anything, come back. This little green button means it's live running in the browser. It says it's gonna, you have to click it twice and it'll run. And then you can actually interact with all of this live in the browser. Panel supports that very well. Datashader does not support it because Datashader depends on Numba. Numba depends on LLVM Lite. LLVM Lite has only been partially built for WASM. So if anything to do with Datashader, it is going to be server-side. But anything that doesn't involve Datashader should work fine without needing a server at all. You can use WASM-based. You saw that it took a little bit of time to download, but now it actually is running dynamically. There's no widget, but okay, well, okay, here's a widget. This should now be live. Yeah, so this is live running in the web browser. There's no server. So this is, Panel supports that. All these tools support it except for Datashader. So people asked about deployment. Deployment is great. Often you do not need deployment. You can just use the WASM-based report stuff, and you can see it in action all over the Panel website, all over the Param website. You will not see it in action on the Datashader website. Yes? We make no assumptions about your data whatsoever when it's on disk. We only make assumptions about where it is in Python. So if it's a Pandas data frame, it will be in Python memory. If it's a Dask data frame, you can access it from Python memory. It might actually be in memory on some other machine. We don't care. We don't know. We don't care. We don't have any opinions about your data or where it's stored. We have only opinions about your data API. That's what we call it. So we know how to deal with Pandas regardless of how the bits were stored on disk. We know how to deal with Dask regardless of what machines they're even running on, as long as you give us the entry point to it. And the same, we know how to deal with CUDA Rapids GPU data frames. It's running on GPU. whatever, we've got some handle on it and we get it to it, and we have the data shader code is GPU based and works with it. So again, that's the performance section of the data shader website. We'll talk about what's supported and the things for which what I said is true, but it's mostly true for just about anything. I could have just not run this tutorial and just answered questions because the questions are so good. So the question was, can you use data shader for things that are not points? Yes. If I go to HoloViews and then user guide, HoloViews have been around a long time. Look at all our user guide. It's a mess. Somewhere in here, there's one called large data that I will need my glasses to find. Oh, there it is. If you go to the very end, you'll see all the things that can be data shaded. Oh, here's time series. Those are data shaded. Here's data shading for, here's the non-data shaded plots, and here's the corresponding thing having been run through data shader. You can compare to see what's the same and what's different. But these are all data shader based plots. So you can do curves, contours, areas, spreads, images, paths, polygons, meshes, polylines, etc. So you can data shade anything. And there's a really cool example from my native neuroscience area, which is under large time series on the hvPlot website. I think it's here, yes. Okay, so this is why you would want to use data shader for time series. This is 3 different experimental conditions and hundreds of runs per each one. And this is what happens when you data shade it. You see that all these green ones are roughly stereotypical, but you can see that the typical place they are and the outlier in the same plot with no overplotting. The same magic that data shader does for individual points works fine for areas, it works fine for lines. It just renders it and then sums up all those pixels and counts the pixels. There are lots of pixels here. You can't actually see it in this example, but you could actually see the counts. But you can see that there are outlier traces, there are tendencies, and there are categorical differences. You can see it all. You can throw millions of traces at it. Normally that would just be an unholy mess of a plot, but not with data shader, because it will respect your data, render it, and show you the dense areas with a color bar. There's not one here, but show you the dense areas, the outliers, and everything in between. And so if you want to know stereotypical events and you just have millions of them, yes, data shader, it'll do it. If somebody is doing rocket launches and they do it over and over while they're testing, they want to see how does this compare to the population of all the other times that parameter was measured. And it always goes like this, except for the one time it blew up and went like that. You can see the blow up very easily against all the rest. So data shader is great at showing you the full distribution of everything and the one weird one that you're currently looking at.
If you have one very long signal, still work.
Yes.
Does it make sense?
Yes. That one very long signal is why you would use, that's just data shade the curve or rasterize the curve. Then when it's all, there's no live processing here, but then you see the entire envelope, including a weird excursion where it went up 1 million times and came back, and where it's spending all of its time. So yes, it'll work there. And the same for any other plot type for data shader. Points are the stereotypical case. You can do anything though. The question was, does hvPlot understand awkward arrays? And I am embarrassed to say I do not know the answer. We have done a lot of work on that, and I don't know whether we ever shipped it. Person involved left the company at the time, and I don't remember how they left it, and I don't use awkward arrays myself, but we definitely said, awkward arrays, that's great, we've always needed that. We've had hacks and workarounds, and my goal was, we have this library called Spatial Pandas that handles awkward data structures, and we'd love to delete that and replace it with Awkward Array, which is a real library that originally was specialized only in physics, but they've really done a lot of work to try to make it be generalizable, and it'd be great. Just like Xarray, came from climate science. It handles microscope data just as well. Let's do it. Same for Awkward Array. Let's do it. Let's agree on basic data types, and everybody respect it. We have not been paid to respect it. We were paid a little to respect it, and I don't know the outcome of that. If it doesn't work today, then it should, and we totally can. But yes, and same for sparse. We have never been paid to support sparse matrix libraries. We should, yes. We haven't been paid to do that. So whatever I try to show, that's 4 hours, and we've been working for a decade. We've done a lot of work on streaming data. That's the question here. I kind of alluded to that when I talked about dynamic map, where it's a function, and every time you do it, it could give you a different result. That's how you do streaming. Streaming can just be anything. If it's going to be watching a file, if it's listening to a connection, whatever. I have some streaming examples with hvPlot that measure your CPU temperature, let's say. It's just polling, like, okay, what's the temperature now? Plot that, and so on, and it updates the data structure. None of these plots care whether your data is streaming or not, because there's so many other ways it could be dynamic. Even if you're just selecting it off disk, it's all the same. It's just new numbers. I'm dealing with new numbers. There's some UI aspects to streaming, like how updating it over time and being able to move forward and backward in history. We actually have some recent improvements there. But streaming just works because everything's dynamic. Thank you. All right, thanks to everybody. It's been a pleasure. All done.
At the plotting one, I was starting to worry because you were taking a very long time. I thought you wanted to do the whole.
Oh, there's no way to do the whole, and plus the last couple really have not been updated. I mean, they work.
Yeah.
I made sure that they work, but they are they're using HoloView streams. And like, come on, people's brains cannot fit HoloView streams in the same day as hvPlot, data shader,
Yeah.
reactive expressions.
Wow.
Come on. So until those get streamlined and greatly simplified, it's really not practical. It's an all-day tutorial and preferably half day, and
Yeah.
then wait a couple of days.
Probably.
Come back with questions and then have another half day.
I don't think you can jam them too much.
No, brains don't work like that. So I'm trying to be respectful of that. And plotting stuff is important. Is that you have to have the plotting stuff and the reactive expressions. By itself, that's already enough. And then everything else is like
Yeah.
another day.
Too intense.
Yeah. And I found there seemed like a natural break in there in the notebook, so I was happy with that. And I'm glad the timing, it worked out to cover exactly what I thought I'd cover.
Yeah.
It's all right.